All right, yo. Gonna go on my phone to test. But welcome back to another live stream. I'm gonna be solving Leetcode problems because I have no life. Now I do have a life. It's just I wanna get into a big tech company, so that's why I'm doing what I'm doing. And hopefully all my effort will be rewarded. So let's see if I'm actually live right now. All right, I am live. And I gotta stop smacking my lips.
And I gotta stop smacking my lips. And I gotta stop smacking my lips. And I gotta stop smacking my lips. And I gotta stop smacking my lips.
Who the fuck is watching? Oh, it's myself. All right, put my phone in do not disturb. All right, let's get started. It's currently around 7 p.m. I'm gonna stay on until at least like 10. So share the entire screen here. All right. Again, I'm going through this list. I've done like 12 problems today in the live stream for 2 hours. So at least 20 more, hopefully in 3 hours. We're gonna start with top K frequent elements. And there's multiple solutions to this one, but I only know the heap sort solution. So some homework for me is to learn the other solutions. But let's read through the problem and start. So we're given an integer array nums and an integer k. Return the k most frequent elements, and you may return the answer in any order. Okay. So here, this is our input array, and we need to return the top two frequent elements. So we see one appears 3 times, and two appears 2 times, and three appears 1 time. So the top two most frequent elements is 1 and 2. Yeah, so it's pretty simple. Some clarifying question I want to ask. So I'm going to simulate a real interview experience. So I need to ask clarifying questions. So will k ever be greater than num's length? I mean, if it is, then just return basically all the elements, right? All unique elements. So that's clarifying question one. Let's see, two. Should we handle nums equals to no? What else? Uh, that's pretty much it, man. And I guess like three, frequency of each unique num will not exceed int range, so no like overflow, right? And that's about it. So my approach for this is using a hash map of num and the frequency of that number, and putting each unique number in a min heap of size k. And another solution is same, using the hash map of number and frequency, and putting each unique in a max heap of size n, and putting every unique. So the first solution, the time complexity is going to be O n log of k, and the space is going to be O of log of k, where n is total number of elements. And basically, well, it would be like unique elements, and k is given to us, so it would be like m plus n log k, because we need to go through all the nums to get the frequency. So m would be the number of elements in nums, and then once we have all the unique ones, we just need to go through and insert it into the heap and maintaining the size of the heaps. So each insertion and removal in a heap of size k would take log of k time complexity. And the reason, well, this would be a max heap, first of all. The reason why we are using the min heap of size k is whenever the min heap exceeds size k, we can just return from pop from the top of the heap, which will return the least frequent element. So by the end, after we've added every unique element in nums, we are guaranteed that the min heap will be of size k and containing the elements that appear the most, because the elements that appear the least will get removed in the min heap whenever the size of the heap exceeds k. And so that's why it's m n log k. And the second solution, the time complexity, would be O of n log n, where n is greater than k, and n is number of unique LMs in nums. So it's less efficient, and the space is O log of n. And if we use this solution, we just need to pop k number of times after adding every unique number to the max heap. And the top k elements in the max heap will be the elements with the most frequent. So this is less efficient than solution one, because the heap size is really big. So if n is like a million, right, there are a million unique numbers in nums. However, k is only 2 or like 10, then it would be very inefficient. Versus where here we maintain a heap of only size of n, I mean a size of k. So if nums is like a million and k is only 10, then this would be much more efficient. So I'm going to go ahead and implement solution one. Okay. So let's do a map of integer and integer. Call it frequency. It's a new hash map. Okay. And then we basically go through nums and populate this frequency hash map. So for int n in nums, first of all, frequency put for n, frequency get n, or the default value if n hasn't been encountered before would be 0. So get or default, and then +1. Okay, so this is populating the frequency map. And then we need our min heap. So it would be a queue of type integer. Call it min heap is a new priority queue. And when we are comparing two elements, A and B, we just got to get their frequency. And it's a min heap, so it would be frequency get A minus frequency get B, just like that. And so now we need to go through every unique number in the frequency table to populate the heap. So for int k in the, or int key in frequency key set, we just do a min heap add the key and then check the size. So if min heap size is equal to k, then we need to remove, well, is greater than k now, then we have violated our min heap of size k. So we need to remove the element that appears the least, because we are trying to store the k most frequent elements in the min heap. So we would do a min heap pull or remove. Just like that. And then at the end, we need an integer array, call it answer is a new int of size k. And then we can do a for int I equals to 0, I is less than k, I plus plus. So answer index I would be equals to min heap remove. So by the end of this, we just return our answer, and the most frequent elements in answer will be ordered from least frequent to most frequent, but still the answer would contain the k most frequent elements. Cool. I'm gonna submit. All right. So yeah, they suggested a bunch of different editorial solutions. So they do a heap one, quick select. I need to learn. It looks complicated, but once I think I understand it, it should be good. All right, next one. This one is a tricky one. Least recently used cache. It's tricky because the concept is not difficult to understand. However, to implement it is difficult. So I'm gonna reset the timer here. We are flying through this list. We have these questions left. Goal is to at least get through like 2/3 of them today, and we have like 2 hours, so 3 hours. So yeah, we should be good. Hopefully. So least recently used cache, we need to design a data structure that follows the constraint of a LRU cache, and the class basically the constructor initializes the least recently used cache with positive size capacity. And for the integer get key, we need to return the value of the key if the key exists. Otherwise, we need to return -1. Okay. And I'm assuming since we are, you know, getting a key, then this has to be the most recently used element. So we need to maintain and update the recently used cache somehow, like the ordering of it, to know which element to remove. And then put key and value. We need to update the value of the key if the key exists. Otherwise, add the key value pair to the cache. Okay. So if the key exists, update that value, and I'm guessing move it to indicate that it was the most recently used value. And then if it doesn't exist, you need to add the key value pair to the cache and also make it the most recently used element. Mark it somehow. And if the number of keys exceeds the capacity from the operation, evict the least recently used key. And get and put must each run in O of n, O of 1 average time complexity. So this is the constraint for it. Okay. So some clarifying question: will the capacity of the heap ever be like 0? Okay. And can I implement additional inner classes to make this efficient and meet the constraint requirement? Okay. So for get, in order to achieve get for a particular key to be O one-time complexity, we can just use a hash map where the key would just return the value associated with that hash map. However, for put, we need to maintain a least recently used order somehow, from most recently used to least recently used. And we also need to add to the most recently used and indicate that an element is most recently used somehow. I'm thinking of using a list structure where the list would be at max of site capacity. And whenever we use or create a new element, we need to move this element at the front to the front of the list to indicate that it's the most recently used item. And whenever we need to remove an element, we just, because the capacity has been reached, we remove whatever is at the tail of this linked list and add the newly added element to the front of the list. So if it's just using an array list, the time complexity of removing an element from remove an element to move it to the front is O of n. So this doesn't satisfy the O of 1 average time complexity for put. And so I'm thinking of using a doubly linked list, and the map would contain the key, and the value would be the node in the linked list, in the doubly linked list, that is corresponded to this key. And that way, whenever we need to remove a node, we can access it in O of 1 constant time. And since it's a doubly linked list, we can access the previous node and the next node of the current node that is being removed in constant time to do the list manipulation to remove the current node from the list and either delete it completely or move it to the front. So my solution will combine solution one, combine doubly linked list with hash map. So the map would be key to the node with the value of the key and 2 pointers, previous and next. And yeah, whenever a node is used, remove it from linked list and add to front. And then whenever cache is full, remove last node in list and add new node to front. So we see that there are many cases we got to take care of here. So for my doubly linked list, the cache will have a head and a tail node to access front and back in constant time and reduce edge cases when removing and adding to front and back. So basically, this will ensure that at least 2 nodes are in the cache at one time, like head and tail. So we remove the no checks. So I think I will implement my doubly linked list node class. So public class, call it node. It will have a int for the key, an int for the value, a node for the previous, a node for the next, because like we said, it's a doubly linked list. So now it's the constructor here. Public node takes in the int key and the int value. And then we just set this key equals to key, this val equals to val, just like that. Okay. So for our cache, like I said, we need always need a head and a tail. So head will always point to tail and tail will always point to head by the previous. So head and tail, we need an int capacity. I'll just call it cap. And then we need a map of integer to node. Call it key to node. And for the constructor, we just initialize head as a new node of -1 and -1. And tail is equals to a new node of basically -1, -1. Okay, so head next always points to tail, and tail previous will point to head initially. And then capacity would be equals to initialize here, and key to node would be initialized to be a new hash map, just like that. Okay. So for the get function, we let me just outline the logic here. So check if key is present in map. If not, return 1. If present, remove node from list and move to front since most recently used. And then for the put function, so if key is present, update with new value, remove from list and move to front, similarly to this logic here. And then if key is not present, check capacity and remove least recently used if at capacity. Then create and add new node to front of list using head reference. Okay, and then also need to update the hash map. Okay, update hash map here too. So we see here we need to remove the node a lot and then move to front a lot. So I'm going to go ahead and simplify my logic by creating two helper functions that will be private, and one will take care of the remove, which is like disconnect the current node from the tail, I mean the previous and the next, and another move to front, which will use the head as reference. So let's do a private void remove, and then a node, call it to remove. Okay, so we don't need to check for null. That is the beauty of this solution, because we will always have the head as the previous and the tail as the next in the case where there's only one element in the heap. So we can always do a to remove previous next would be to remove next, and then to remove next previous would be to remove previous, and then we need to disconnect this list. So update previous and next pointers of node being removed, and then here we are disconnecting. So disconnect to remove previous equals to null, and to remove next equals to null. Okay, so this is my remove function and the to front function. So private void to front, and then node to new front. So we know that whatever head next points to will be the most recently used node. So this will be the front of the list. So we can get a node, call it like the old front. So the node that is now going to be second in the head of the list after we add the new front node. So old front will be head next. And now it's just simple manipulation of the pointer. So old front previous now points to the new front. New front next now points to the old front, and then now head next now points to the new front. So now new front is the most recently used item, and then new front previous you want to point it back to head. And this is my to front function. So now that I have these two functions, I can just follow the logic here to implement my code. So let me get the node. The target is equals to basically key to node get the key. So if we don't found the node, so if target equals to null, we immediately return -1. Otherwise, it's present. So we need to remove this from the current position in the list. So we do remove target, and then to front target, and then we just do a return target value. Very simple and straightforward. Okay. Similarly here, we get the node target is equal to key to node get for the key. So if the key is present, we need to update it with a new value, remove from the current position, and move to the front. So if target doesn't equals to null, then we do a basically target val is equals to value, and then we remove target, and then we add to front the target, and then we just like that. Otherwise, this is the else case. So let me just copy this logic up here. If the key is not present, check the capacity and remove least recently used if at capacity, and update hash map, then create and add new node to the front of the list. Okay, so let's do it one step at a time. So check capacity. So if basically now hash map, well, it would be key to node size is equal to the capacity, then we remove the tail. So least recently used. So node to remove would be equals to tail previous, and then we call remove to remove. So this disconnects the tail from the hash map, and we need to remove the tail. I mean, we need to remove the least recent use from the key to node hash map as well. So key to node remove, basically to remove value. Okay. And then now, if the map is now, this if condition will guarantee the map is at capacity, is less than capacity before we add the new element. So node new front would be equals to a new node with the specified key and the specified value. Okay, we need to add this to the hash map. So key to value, we do a put for the key, a new front, just like that. And then we need to add this to front, this new front, and this would be basically my logic. Key, oh, this would be key to node. Key to node. Let's see here. What line is it saying? Here to remove, okay, we are having an issue somewhere. So if the target is null, we return -1. Otherwise, we remove the target. Okay. So if the target doesn't equals to null, we update the value, we remove it and add it to the front. Okay. If the key to node size is at capacity and we are trying to add a new node, then we need to remove it by calling remove right here, and we remove it. Oh, this should be the key to remove key, because we need to remove whatever the key is from the hash map. So this should work. Cool. Excellent. So yeah, I think my brain was on autopilot here, and I should remove the key, not the value, because the map is taking in the key. Okay. Okay, so least recently used cache is done. Let's see how are we doing on the live stream. 26 minutes. So it took me 16 minutes to do that problem. Wow. Next permutation. Okay, closest points to origin. Copy list with random pointer. And then we have these problems. So counting down the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 more problems. Well, 27 if it's this one. Okay. Next permutation. So a permutation of an array of integers is an arrangement of its members into a sequence of linear order. Okay. For example, array 1, 2, 3. The following are permutation of array. So 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. The next permutation of an array of integers is the next lexicographically greater permutation of its integer. Okay. More formally, if all the permutations of the array are sorted in one container according to their lexicographical order, then the next permutation of that array is the permutation that follows in the sorted container. If such arrangement is not possible, the array must be arranged as the lowest possible order. Okay. Cool. That makes sense. So the next permutation of 1, 2, 3 is 1, 3, 2. So we swap the 2 and the 3. 2, 3, 1 is 3, 1, 2. That makes sense. Okay. And 3, 2, 1, it's already at the max. So we return 1, 2, 3. That makes a lot of sense. Okay. So given the array of nums, find the next permutation of nums. That makes sense. Okay. So Some clarifying questions I have is, uh, can nums contain duplicates? What if nums is all the same number? So for example, like 1111, then we just return itself, right? Will nums be sorted in ascending order? Okay. And will number length of nums be greater than the max int value? Okay. So solution one, I need to basically sort nums and build all permutations in order, and then find convert nums to uh, find the position in sorted permutation list, and the next permutation in list should be returned. So in this case, right, we would sort array to be 1, 2, 3, and then we would build. So it become 1, 2, 3, 1, 3, 2, and then 2, 1, 3, 2, 3, 1, stuff like that. So the time complexity of this would be, say nums has n elements, so it would be n log of n to sort. And then after we sort, we need to build all permutations. So permutations, at the first index, we have n number of choices. At the second one, we have n minus 1 number of choices. So it would be n factorial. And the space complexity for our recursion stack would be O of log n for the sorting plus n. So this is my solution. It's not very efficient. So solution 2, I think we see a pattern here. Say our example is like 1, 2, 5, 4, 3, right? We know the next permutation here should be 1, 3, and then 2, 4, 5, right? That's the next permutation, because here 1, 2, 3, 4, 5, 1, 2, 3, 5, 4. So we notice that if we go from the right to the left, as long as the numbers from right to left are increasing, we're good. However, the first index where it's decreasing, so here 2 and 5, then we can make the swap. So this would be the index where the next permutation would be different. So it would be 1, we swap basically 2 with the greatest number, the first greatest number from the right. So it would be 3 in this case. So our array becomes 1, 3, 5, 4, 2. But then this is not the next permutation. We need to do a reversal of the remaining after the swap index. So it would be 1, 2, 1, 3, 2, 4, 5. That would become the next iteration. So it's like I believe, a two-step process. So logic here, I'm just going to outline it. So step 1, find swap index from right to left where nums at swap index is less than nums at swap index plus 1. Okay, So if can't, we have an edge case here. If can't find swap index. So in the case where it's like 3 2 like 3 2 1 for example, then reverse the whole array and return. So it would be 1 2 3 like that. Otherwise, once found swap index, swap with the first bigger element from right to left. And two, reverse array part of array from swap index plus 1 to n to get the next biggest permutation, because otherwise we don't get the next biggest permutation, like as we see here, right? We found that 2 is the swap index because 2 is less than 5. So we do the swap, we get 1 3 5 4 2. Okay. But that's not the next permutation, so we need to swap reverse 542 to 245, and then we get our answer. So the time complexity of this solution is O of n in the worst case, because first we need to go through n number of elements to find the swap index, and then we need to go through in the worst case n number of elements to reverse. So where n is num of lms in nums, and the space is O of 1 because we are just modifying the input array. That is basically it. So let's have a int swap index, and then let's get the length of the array. So int n is num's length right here. Okay, and then we get swap index would be equals to n minus 1 or n minus 2, because we want to start from the second to last index so we can compare to the next index to the right of it. So for swap index is greater than or equals to 0, we want to do a swap index minus minus. Okay, so let's get if basically swap index, well, nums at swap index, like I said, is less than nums at swap index plus 1, then we have found our swap index. Then we do the swap with first largest lm from right to left and exit for loop. Okay, so if we found it here, we do the swap and then we break out of this loop. So now we have the swap index. Okay, so let's do the swap. So let's have a for int I equals to swap, I mean n minus 1, I is greater than the swap index, I minus minus, because we don't want to swap any elements that come after the swap index or at the swap index. In that case, we are just swapping the number to itself. So we check if basically nums at index I is greater than nums at swap index, then we do the swap right here. Okay, then int temp is equal to nums at index I, and int, well, nums at I would be equal to nums at swap index, and nums at swap index would be equals to temp, and then we would break out of this loop too because we have just done our swap. So now we need to check. We know that in the case where it's like 3 2 1, then the swap index would never stop because the array is strictly increasing from right to left. So the swap index would be equal, well, less than 0. It would be equal to -1. Then we just reverse the entire array. So we pass in nums and from 0. And then just return from here. Okay. So biggest permutation already. So reverse to get smallest permutation and return. Otherwise, we need to do a reverse, basically swap nums, and we want to reverse from swap index plus 1. And that would be my answer. So for the reverse function, so private void reverse, it would take in an int for nums and int for the start index, well, for the left side. Okay. And then the right would be equals to nums length minus 1, while left is less than right. We want to get a temp is equals to nums at left, and set nums at left is equals to nums at right, and nums at right is equals to temp, and then we do a left plus plus, right minus minus, and that would be our answer here. So let me go over the code. So we have n is nums length, swap index is n minus 2, swap index is greater than or equals to 0, swap index minus minus, yes, that makes sense. Okay, swap the first largest element from right to left. So we start from the right. Yep, num swap I is temp. We break out of this loop. We also break out of this loop. We check if we need to reverse the entire array. Otherwise, you reverse from here. Nums at left, left, and right. Okay, so let me run through a quick example. Let me just do this one right here. So I'm going to paste the code down here for better visibility. So we have 1, 2, 3, 1, 2, 5. And this is the index. It would be 0, 1, 2, 3, 4. Okay, so let me do an index, and this would be nums, just like that. And so we have swap index would be n, which is 5 minus 2. So swap index is 3 here. So now swap index is still greater than equals to 0. So we compare. Is 4 greater than 3? No. So we don't enter this if statement. Let me move this down. So now we do a swap index is here. So it's now at 2. Is 5 greater than 4? No. So we decrement swap index. So swap index is now at 1. Is 2 less than 5? Yes, it is. So we enter this loop. We want to do the swap with the largest element from right to left. So we have another int here. So this is where I comes into play. Would be n minus 1. So I is at 4. So 4 is 3 greater than 2? Yes. So we do the swap. Temp is nums index I. So let's do temp is nums at index I, which is 3. Okay. And then nums at index 3 would be nums at the swap index. So this would becomes 2. Okay. And then nums at swap index becomes temp, which is 3. So we have done the swap to 1, 3, 5, 4, 2. And we break out of the loop, break out of the outer for loop. And now we check swap index. Swap index is now at 1. It's not less than 0, so we don't reverse. So we call reverse on nums, passing in swap index plus 1, so nums at 2. So now we call reverse, passing in nums, which is 1, 3, 5, 4, 2. And the start index for the left would be 2. So here, while left is right, we just keep doing the swap. So let me copy nums here. we have left is here and right is here. So we do the swap. This becomes 2. This becomes 5. And then boom, boom. They are touching each other. So we exit this loop and we just have our num as 1, 3, 2, 4, 5, which is our expected answer. So it's a O of n time complexity here. Cool. It's been accepted. Gonna submit. Next permutation is done. So let's see the editorial, the brute force. Yep, O of n factorial. So we just sorted. Single pass. Yep. Next permutation is done. Let's do k closest points to origin. 45 minutes with 2 people watching. Bro, I've just solved it yesterday. Which company are you interviewing for? How do I make this chat like go on the side of my screen so I can just see it when I'm like coding? Because I'm in a new window, so I can't see the chat. But I'm just going through. If you just joined before I started, I'm just going through the meta top tag questions just to review and do space repetition so I can memorize and come up with the most optimal solution during the interview. I have about like 25 problems left. And tomorrow I will be going over the second half here. Still so many fucking problems to do. But yeah, you going for meta? How do I see this chat as I'm coding this shit? And make sure you subscribe, man. But k closest points to origin. Let's do it. Again, this one, there's probably like a quick select solution or something like that, but I'm just going to be using the heap solution. I really need to learn the quick select solution. Heap solution is pretty easy. Oh, you can sort with custom comparator too. Yeah. So let's start the problem. I'm going to start my timer, add a comment block here. All right, k closest points to origin. We are given an array of points where points contains an x and y coordinate, and it represents a point on the xy plane and the integer k. We need to return the k closest point to the origin, and the distance between the 2 points on the xy plane is given using this formula. Okay, x1 minus x2 squared plus y1 minus y2 squared. Take the square root, and we can return the answer in any order, and the answer is guaranteed to be unique except for the order that it is in. Okay, some clarifying questions I have is will there be duplicate points? So for example, we don't want to have like 1, 3, 2 times or 3 times because that would mess up our answer. But okay, will there be duplicate points? Will k be bigger than points? Because in that case, we can just return the points array. Because if k is bigger than points or equal to points, then we already have the k closest points to the origin, which is 0 and 0. And then 3, how do we want to handle points equals to no? Okay, will points ever equals to no? Let's see, no. Okay. And another question is, will the formula, the distance formula, result in int overflow? For example, like if we are trying to square the integer max value and adding them together, that would cause an overflow for sure. Okay, so I'm assuming there's a no. So my solution 1, we can do a custom sort. So from closest to farthest, and So by the end, the first k elements in array will be answer. So the time complexity of this is O of n log of n, and the space complexity is O log of n, where n is equal to number of points, just like that. Yeah, that's basically the solution 1 for custom sort. Another solution 2, is using a max heap of size k, which would have a better time complexity of O of n log k, because the heap is only of size k, and the space complexity would only be log of k. And this would be very efficient in the case where we have like millions number of distinct points, and k is very small, like 5 versus like 1 million points. So this would improve the time complexity from O n log of n, which would be like 1 million log 1 million to 1 million log 5 if n is 1 million and k is 5. So the reason why we are maintaining a max heap is we want to remove the elements that are furthest from the origin. So once the heap is of size k and we try and add another element, this heap will overflow. And well, we want to remove the element at the top of the heap, because that element will be the element that is farthest from the origin, because we are maintaining a max heap. So by the end, after we've gone through points to add to our max heap, it is guaranteed that the max heap will contain k closest elements. So the max heap is the more optimal solution than the custom sort solution. There is another solution here where it's like quick select or quick sort, or binary search. Okay, interesting. I haven't looked at the binary search problem. The quick select solution looks crazy. I really need to learn this. So yeah, let me just solve it using the heap solution and then come back and learn it. Okay, so we need to maintain a max heap, which is a queue of basically, it will be int, call it max heap. It's a new priority queue of comparing A and B. Then we need to do a if distance A is less than distance B, return -1. Otherwise, return 1. If they're equal in distance, you want to return the one that comes first. I guess, yeah, another question that I have is, what if they are equidistant? Like 2 points are equidistant. Which one do we want to return? 2 points equidistant. Which one to choose? Because if the case example k is equals to 1 and 2 points the same distance, okay, so test cases are here. Okay, so we need to make the this function. Before we do that, let me just write up the main logic of the function. So for int p in points, basically we just add to the max heap. Add p, check if it the size is greater than k. So size is greater than k. We need to remove the furthest element. So max heap remove. And then at the end, we have our int call it answer, is a new int. It will be of size k, and we just go through for int I equals to 0, I is less than k, I plus plus. Answer index I would be equals to max heap remove. At the end, we just return answer just like that. Okay, so now the last one is finding the distance. So we just have to implement this formula. So it would be a private double distance. Let's do a int point. So we just need to do a return. It would be, we are minusing 0 here, so it would just be point at index 0 times point at index 0 plus point at index 1 times point at index 1. And then we would do a math sqrt like that. Spelling error, get a wrong answer. We are returning 1 and 3. So is there something wrong with finding the distance formula? Here, the formula would be 4 plus 4, square root of 4. I mean square root of 8 versus square root of 10. Yeah, so obviously, oh, it's a max heap. So this and then this, because now the logic is flipped. Cool. Yeah, not bad. K closest points. I'm gonna leave the top K shit here so I can learn the quick select solution. Let's move on to the next copy list with random pointers. Ooh, one person watching. Nice. All right, copy list with random pointer. I'm gonna start my timer here. So we are given a linked list of length n, and each node contains an additional random pointer. So a clarifying question I would ask here is, what is the structure of the node? Will it only contain a value and a next pointer and a random pointer, or what will it look like? And this would be confirmed by my interviewer here. Contains a random, a next, and a val. Okay. And we need to construct a deep copy of the list. And the deep copy should consist of exactly n brand new nodes, where each new node has its value set to the value of its corresponding original node. Both the next and random pointer of the new nodes should point to the new nodes in the copy list, such that the pointers of the original list and copy lists represent the same list state. So basically what it's trying to say here is we just make a deep copy and make sure the random and the next pointer of every element in the deep copy is pointing to the deep copy nodes, not to the original nodes. Okay. So yeah. And we are only given the head of a linked list. Okay. So an example here, 7 points to 13, but it's random points to no. 13, it's random points to 7, and its next point to 11. So yeah, there are a few clarifying questions I want to ask. If, let's say, if head is equals to no, then we just return no. How do you handle that case? Obviously clarify the node structure. And 3, let's see. That's about it. I mean, we want to do a no cycle, just to make sure that we don't go into a cycle in linked lists, because that would be hard to determine. Okay. And 4, unique values in list. Let me check the constraints. is no. So it's not guaranteed that it will be unique right here. No. Yes. Okay. And so the first case we can check. Well, let's go over the solution first. So solution 1 is maintain a hash map of node to deep copy and do a DFS to build the random to build the copy list and populate next and random pointer. Okay, so the time complexity of this is O of n, where n is num nodes in list. Space is O of n because hash map. So I'm gonna do this solution first before I implement the second solution. Is store copy as next pointer in current node. So for example, if we have like 1, 2, 3, then we would have our copy. After we make the copy, it would be 1 to 1 to 2 to 2 to 3 to 3, like that. And then this is first pass, and then second pass would be populate random pointer in copy node list. So we can do like if current random doesn't equals to null, then current next random would be equals to current random next, because we know that the copy of the random node will be in its next node. And then the third pass would be to separate the two lists and return copy head. So the time is still O of n. It's 3 pass, so 3n, which simplifies to O of n. But the space now is just O of 1 because we are just making the copy. I'm assuming the deep copy doesn't count towards space complexity. Okay? So let's do solution 1 first and then do solution 2 because I like this problem. All right. So for solution 1, we need our map. It would be map of node to node. Call it node to copy. And right away, we can see a base case. If head is equals to null, we can just return null. Otherwise, we initialize node to copy. It's a new hash map, just like that. All right. So we have node to copy is a new hash map. And now we just do a DFS on head. And at the end, return node to copy, get the copy of head. So most of the logic will be in the DFS function. So private node DFS takes in a node current. So we check if current equals to null. We can immediately return null. Otherwise, we need to make the copy. Well, if basically node to copy contains key for the current, we can do a immediately return node to copy get current, just like that. Okay, so now if it doesn't, then we do a node copy is equals to a new node that contains current value. And then now we need to populate random and next pointer. Okay, so we need to do a copy next is equals to DFS on current next. Okay, and then, well, that's if it's not null. So we can check here if copy, well, if current next doesn't equals to null, we can do that. And then if current random doesn't equals to null, then we do a copy random is equals to DFS current random. And then we need to add this to the hash map. So node copy put copy, current the copy, and then at the end we just return copy, just like that. And this should make sure that our node gets taken care of. Cool. This is the DFS solution. So let me mark it here. This is DFS. Okay. We can continue my timer so I can implement solution 2, the 3-pass solution with O of 1 space. So we don't need the hash map. We don't need a private function. So let me delete this hash map. So again, like I said, we need to do the first pass, store the current copy as next pointer in current node. So node current is equals to basically the head, while current doesn't equal to null. And then we do a node copy is equals to a new node that contains current value, and its next should point to current next. So now we can do a current next would be copy, and then current is equals to copy next, just like that. Okay, trying to think if there's any condition I should check for here. So if the node is only 1, then current next, let's see. Copy would be 1 and points to null, and then copy is equals to null. So I don't think the first pass we need to check anything here. So now we do second pass to connect random pointer. Okay, so current is equals to head again, while basically current doesn't equals to null. We just check if current random doesn't equals to null, then we can do a current next, which is the copy random is equals to current random next, just like that. And then we can do a current is equals to current next to move on to the next node. All right, so we've done the second pass. So now third pass to separate the two lists and return the copy head. So node copy head is equals to current next, and then current is set to head again, and then we have another node current copy would be equals to copy head, and then we separate the list and we just return copy head, just like that. Okay, so the condition here is while current basically doesn't equals to null, because we know that when current is null, we are at the end of the list. So we can do a current next would be equals to current next, and we want to check here. So if we are at this case, right, we would have like 1 1 and 2 2. So the case where it's 1 1 and 2 2. So when current is here, current next, so current copy would be here. So we don't want to, we need to check if current copy next doesn't equals to null. Then we can do a current copy next is equals to current copy next, and then we move current is equals to current next, current copy is current copy next. So this takes care of the case where current is here and current copy is here, right? So current next would point to current next. So 2 would point to null. So null here. And then current copy is here. If we don't have this check, we're going to try and do a current copy next, which is null, because 2 next is null, and next again. So we're accessing a next of a null pointer. So that's why we need that. And then at the end, we just return copy head. That is, of course, I miss a semicolon. Okay. We forgot to reset here. So current should be reset here. And then current copy. Cool. This is the one pass solution. Nice, man. Some small hiccups here and there. Make sure to reset current to head first. Make sure to do the dry run. So let's do the test cases here, right? So test cases 1, no head. 2, linked list with no random pointers. 3, linked list with some and all random pointers. 4, linked list of size 1. Yeah, this pretty straightforward question. Cool. All right, next one is threesome, and I'm not gonna solve twosome, so I'm gonna move on to diameter of binary tree and building with an ocean view. Okay. So after this, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Moving through it, man. Moving through it. Almost, an hour into the stream. God damn. All right, threesome. Let's start my timer. So we are given an array nums. We need to return all triplets nums I, j, and k such that I doesn't equals to j, I doesn't equals to k, and j doesn't equals to k. And the sum of the elements at the index ijk adds up to 0. And the solution set must not contain duplicate triplets. So let's walk through some example here. We see that -1 is -2, +2 is 0. So that's part of the output. -1, 0, and 1 is part of the output as well. So yeah, that's all the distinct triplets. So I guess looking at this, some clarifying questions that I want to ask is, will there be duplicates in nums? And the answer is going to be yes. I'm just like going through what I would do in a actual interview by asking clarifying questions, even though I can just look at them in the constraints here. So the second clarifying question is, will nums be empty or no? How to handle? We just return an empty list, and we check here nums length will at least be 3. So that case will never be encountered. And let's see. 3, will sum of 3 elements exceeds max int value? That would be another clarifying question I want to ask. So negative, unique, invalid inputs, and overflow. Okay, so now I'm going to check with some solutions. So solution 1 is brute force. It would be we just have 3 for loops and compare all 3 triplets, and any triplet that is part of the answer will be added, and we can just eliminate duplicate triplets by checking if that set of triplet has already been found. So brute force, the time would be O of n cubed, where n is length of nums, and the space complexity would be O of 1. Okay, solution 2, I can do a 3-pointer approach and skipping duplicates once an answer is found. So to have a 3-pointer approach, 3-pointer sliding window approach. So 1, I need to sort the array. So dup elements LMs are next to each other. And then for 2, it would be first pointer from left to right in sorted input, and then left and right pointers at first pointer +1 and last lm in nums, and then get current sum and adjust sliding window. If current sum is greater than 0, shrink right, else shrink left. So yeah, that is basically my answer. So the time is O of n squared. Space is O of n squared. Space would be O of log n for the sorting, where n is the length of nums. That would be my two solution. I think solution 2 is more optimal, so I'm going to go ahead and do that. So first we want to call array sort nums, okay? And then we want to have 3 pointer. So we want to have our answer list as well, which is a list of integer. Call it answer list is a new array list here. So now we have our 3 pointer approach by maintaining a for loop for the first pointer. So let me get the length of num. So int n is num's length. Okay. For int I equals to 0, I is less than basically n minus 2, because we know that we can stop once we are at the third last element in the array. We don't want to visit the last element and the second last because we need to find triplets. Okay. Then it would be a I plus plus right here. Okay. So int, let's do a x is nums at index I. And then now we have a left would be equals to I. Well, left is equals to basically I plus 1. And int right is equals to n minus 1. Okay. So now we need to find the current sum. So while left is less than right for our sliding window, we do a int current sum is equals to let's do int y is equals to nums at left, int z is equals to nums at right. Okay, so current sum would be equals to x, y, and z, x plus y plus z here. We check if current sum is equals to 0, then we add this triplet to our answer, and we need to move our pointers to avoid duplicates. Okay, so we do a list of integer triplet is equals to a new array list that contains arrays as list. Basically, x, y, and z. And then answer list would add the current triplet. And we want to basically return answer list at the very end. Okay. And then we want to remove duplicate pointer. So we want to do a left plus plus and right minus minus here. So while left is less than right, then if basically nums at left is equal to y, so we can combine while left is less than right and nums at left is equals to y, then we do a left plus plus. And similarly for the right, we want to do a while left and right, and num at right is equals to z, then we do a right minus minus. So this will take care of the duplicates. So the else case here is if current sum is less than 0, then we want to do a left plus plus. And then else we want to do a right minus minus to try and get current sum to be equals to 0. Okay. So another case here, we haven't taken care of the duplicate x. So if basically I is greater than 0 and nums at I minus 1 is equals to nums at I, then we know that this is a duplicate. We need to skip. So by saying continue. And this should take care of everything and return the most optimal solution. Let me run it. Cool, it's accepted. I would probably be expected to do a dry run in this problem. So I'm going to copy a small example of 4 here and just run through this. So dry run example here. Oh. Okay, so this is already sorted. So we want to set I to here. I is still less than basically n minus 2. 4 minus 2 is 2. So n is still less than 2. So now we have left and right. So left is here and right is here. So we have current sum is -1 plus 0 plus 2. So it's now 1. Current sum is not equals to 0. Current sum is 1, which is greater than 0. So we do a right minus minus. So right is here, okay? Left is still less than right. So current sum is now -1 plus 0 plus 1, which is equals to 0. So you add this current triplet of x, y, and z to the answer list. We do a left plus plus and right minus minus. So left plus plus and right minus minus. This while condition is no longer true. Well, we do a left plus plus here. So, and we exit the loop and we never enter this loop. Okay, then we go out. Left is no longer less than right. So we exit out of this loop and we do a I plus plus. So I is now at 0. Okay, and then our answer list will contain -1, 0, and 1. So let me do an answer list. Will contain -1, 0, and 1. Okay, so now we have left and right like that. Y and Z, and current sum would be 0, 1, and 2, which is 3. So we do a right minus minus. It's here. And we check. This is no longer true. So we exit out of the while loop. We increment I. So I is now equal to n minus 2 because n is 4, minus 2 is 2, and I is at 2. So we exit and we just return our answer list. So I'm going to submit this. And it works. Cool. So the dry run works. Solving problems pretty fast now because I've done them like fucking hundreds of times. Oh, yeah. I hope I answered your question for the dry run. Neon. Sorry, I just saw your question. Did I answer your dry run question? Because I can revisit it. So the duplicate values in the first pointer will be taken care of by this if statement. And the duplicate value in the left will be taken care of in the this while loop here. And the duplicate values for the right will be taken care of here. So that's like the 3-sum problem. I hope that makes sense. Let me know if you're still watching. All right, 3-sum is done. We have a few problems to get through here. Around 20 more problems, and we are about an hour and a half into the stream. The diameter of a binary tree should be easy. All right, reset my timer here. We are given the root of a binary tree. We need to return the length of the diameter of the tree. And the diameter of the binary tree is the length of the longest path between any two nodes in the tree. And this path may or may not pass through the root. So what this is saying is that every node in the tree could be the node that contains the longest path. And the length of the longest path between two nodes is represented by the number of edges between them, okay? So if this was a real interview, I would have some clarifying questions right here. So I would first confirm the structure of binary tree. Is it a tree with a left and a right pointer and a value? Yep. So in the case, the interviewer would confirm this to me. And then 2 is root equals to null. How do you want to handle this? Just return 0. And also, if root is the only node in tree, then we return 0 as well. And what other cases can I think? I want to check for integer overflow. So will path be longer than int max value? I think these would be the clarifying questions I would ask. And so now I would go into the solution. So solution, the only solution I could possibly think of is a DFS solution, and with a global longest length, basically. At every node, get path from left and right subtree, then compare with global longest, and pass up to parent DFS function the longer path length between basically left or right, and then +1, because we need to take care of the edge. So let me do a quick run through here before I dive into the time and space complexity. So we code DFS on 1, which would code DFS on 2 and 3. So when we're at 2, we code DFS on 4 and 5, which would return 1 respectively. So 1 and 1. So the longest path so far is 2 for 4, 2, and 5. And so what is the longest between these left and right subtree? It's 1. So we return 1 plus 1. We return 2 back up to 1. And then the function call for DFS of 3 will return to 1. So 2 plus 1 is 3. And that is basically our answer. So the time complexity of this is O of n, because we need to visit every node in the tree. So where n is num nodes in tree. And space would be O of n, where n is number of nodes in tree. In the worst case where tree is linked list. So in case where the tree is a balanced tree, then it's O of log n. So we can simplify to be O of height of the tree as the space complexity. Okay, so let's go ahead and implement this solution. So edge case, if root is equals to null, we just return basically 0. And then we can do an int longest, and we can initialize longest to be 0 here. We call DFS on the root, and then at the end we just return longest like that. So now private void DFS takes in a tree node current. So a base case here, if current is equals to null, we want to return 0. If current is a leaf node, so current left equals to 0, current left equals to null, and current right is equals to null. Before we return, we need to update to see if this is the longest. So longest is equals to math max between the longest or 1, and then we just return 1 here. So this takes care of the case where root is the only node in the tree. So we set longest equals to 0. We call DFS on root. We check that root is the leaf node, so we have to update longest to be 1, and then we return 1. Okay. Otherwise, we need to get an int left path, left length would be on DFS current left, and then int right length is DFS current right, And then we need to compare longest is math max between the current longest or the left length plus the right length, like that. And then we just return 1 plus the math max between left length and right length. This would be my solution. It's a pretty straightforward problem. If current is null, oh, this should be an int return type. We get a wrong answer here. Oh, yeah. We don't update the longest because the edge case where it's the only node in the tree is a leaf, then yeah, there's no path. So it should, yeah, cool. Yeah, pretty straightforward solution. Building with ocean view is pretty easy too. Oh, there's 4 people watching. What is up? For the people who just joined, I'm just going through Meta's top tag questions to prepare for my interview. So we are here now, and my goal is to get to the top. So I think today my goal is to get through the top 40. So I started clone graph, and I've gone up to about halfway to building with an ocean view, and I've got a bit over halfway up in terms of number of questions to go through. So let's do building with an ocean view. Thanks for turns out I was a bit behind. Oh, okay. Yeah, thanks for the comment, man. Let me know if you are practicing for your for any upcoming interviews, because I'm practicing for mine. So that's why I'm doing this. So building with an ocean view, and also make sure to subscribe. I would really appreciate it. All right. So let's restart my timer here. So there are n buildings in a line. You are given an integer array heights of size n that represents the heights of the buildings in the line. Okay. The ocean is to the right of the buildings, and a building has an ocean view if the building can see the ocean without obstructions. Formally, a building has an ocean view if all buildings to its right have a smaller height. This is like the key here. So we need to return a list of indices, zero index of buildings that have an ocean view, sorted in increasing order. So the return type, I'm guessing, would be a nums array, starting from the left to the right, containing indexes of buildings that have an ocean view. Okay, so let's go through an example here. Heights would be 4, 2, 3, 1. So we would see that the indexes are 0, 2, and 3. So 4 is greater than every building height to the right of it. So of course it can see the ocean. 2 is blocked by 3, so that's why it's not included in the output. And then 3 is greater than 1 to the right, so 3 is included, which is index 2, and then 1 is the rightmost element, so of course it's included here. Okay, so some clarifying questions I would ask before I begin this question is, one, will there be a case where heights is equals to null? How to handle, my computer is freezing here. I'm assuming we would just return a empty int array, but then we check the constraint here, so the interviewer would confirm to us how they want us to handle the case where heights is null. Okay, and then we want to check if two buildings have same height, can left building view ocean. So this would be the case where, like the height is 3 and 3. So I'm asking whether we stand here, can we view the ocean? Because realistically, if two buildings are of the same height and you stand on the leftmost building, you can still see the ocean. However, in this case, the answer would be no. Okay, so it has to be strictly greater from the left to be able to view the height. And let's see. I think that's about it for, I guess we can ask like the range of heights. Like I'm assuming there would be no negative height, so no building are like built into the ground. And that's about it. So this is a good problem because there are many really simple solutions. So solution 1 would be using a stack, and it would be like a monotone decreasing stack. and the time complexity would be O of n, because we need to visit where n is all the buildings in heights, and the space for our stack in the worst case scenario will be O of n. And I will come back and explain the stack solution, and I'll probably implement both. So solution 2 is more efficient. Time is still start from right to left, keeping track of highest building seen from right. And then if current building height is greater than highest, then add index to answer list. That's basically it. So the time complexity would still be O of n here, and the space complexity, however, is just O of 1, because we are just storing one variable, highest building seen from the right. Okay, so obviously in an interview, I would have to implement this solution. However, I want to explain my monotone stack solution. So we say we have this array. Our stack is here. So we go from left to right. So we currently add 4. Okay. And then when we're at 2, we check the stack isn't empty, and we check whether 2 is 2 can be seen. Yes, because 2 is not greater than 4, so we can still see that. And then finally, we add 3 here. We know that 3 is going to block 2. So we want to basically remove 2, and now we compare 3 to 4. So 3 is strictly less than 4, so we can add 3 to the top of the stack. And then finally 1, we compare 1 to the top of the stack. 1 is basically less than 3, so we know that it's not going to block 4 or 3. So this would be our answer. So instead of storing the actual building heights itself, the stack would just contain the index of the heights. So it would be 0, 2, and 3. And then we just go through the stack and add these indexes. So that's the monotone decreasing stack solution. We want to make sure that if we go from the bottom of the stack to the top, the elements are strictly decreasing. That's basically the logic of it. So I can implement this. So let's do a stack of integer, call it st as a new stack, and this would store the indexes. Okay, so for int I equals to 0, I is less than nums, is it heights length I plus plus. So let me copy this, and basically let's get the current height. So int ch, so current height is equals to heights at index I, and then we check if basically stack is empty, then we just push the index onto the stack. So we do a set st push I. So else, this is when the stack is not empty. We want to compare current height with height at top of stack. Okay, so we check while st is not empty and st peak, we want to maintain a monotone decreasing order. So if st peak is less than or equal to the current height, then it means that this current height will block whatever is at the top of the stack. So we want to do a st pop, just like that. So now when we are here, we know that we can add the current height to the top of the stack. So st push, it would be the index. So we push I. So what are the cases when we finally get to line 38? When the stack is empty. So in a case where, for example, it's like 2, 1, and the current is 5. So if the stack currently has 2, 1, then we add 5, it will block from the right 2 and 1. So we need to remove both. So then stack would become empty. So stack will only contain 5. And then another case, if it's like 6, 4, or 6, 3, and we are trying to add 5, then we would only need to remove 3. So we know that 6 and 5 can view the ocean. So that's this case here. So at the end, we have our answer list. So int answer is a new int of size st size. Okay. So for while stack, well, we can just go through int index is equals to 0, and we go from the bottom to the top of the stack. So for int n in st, basically answer the current index would be equals to n, and then we do an index plus plus, and then we just return our answer. We get a wrong answer here because we are skipping this index for some reason. So there's a bug here somewhere. So stack is empty, then stack push I. Okay. So while stack is not empty and stack peak, oh, this would be num or heights, because this is getting the index. So we need to get the height at the current index that is on the top of the stack. So quick bug and boom, O of n, space complexity. So now let me do solution 2. Resume my timer, where we start from the right and we go to the left and keeping track of the highest building seen. So let me remove all of this. Okay. And here, we would still need a stack, I guess. Let's do a stack here. Well, it doesn't really matter what data structure. So we go from right to left. So we want to do a highest from right is equal to basically -1, right? And so now for int I equals to basically let's do heights, copy here, heights length -1, I is greater than or equals to 0, I minus minus. So we get the current height. So current height would be equals to nums or heights at index I. So we want to see if the highest from the right is blocking the current building. So if current height is greater than basically highest from right, let me just copy this, then we know that this building of the current height can view everything to its right because it's greater than the highest building to the right. So we want to do a stack of integer, call it stack is a new stack. This will store the indexes. Okay. So we would do a st add the index. So I here. And then we need to update highest from right is equal to the current height. Just like that. And so at the end, we have our answer is a new int, the size of the stack. And then we need to do a int current index for the answer list right here is equals to 0. So while the stack is not empty, we need to pop all the indexes that can see from to the right. So answer at the current index would be equals to st pop, and then index would be plus plus, and then at the end we just return our answer. So this would do the solution in O of one space. All right, 11 minutes on this question. Yeah, linear iteration, a brute force way, O of n. Yep, monotonic stack. I went over that one. I don't know. Yeah, building with ocean view is done. Am I working in Fang? Make a guess. If you think I work in Fang, you should subscribe. All right. So we got 1 person watching and 2 likes. Nice. Thank you guys for the support. We got valid palindrome. Pretty easy. I guess. Yeah. I was just. Do I need to do valid palindrome? It's so like stupidly easy. Nah, I'm not gonna do valid palindrome. Range sum of BST. Move zeros. This is a fix. That's a difficult one. So I want to prioritize by doing that one first. Almost there, guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 problems. And we've been live for about almost 2 hours. So, quick water break. Hope you guys are enjoying the stream. And I don't need this gum. All right, shortest path in binary matrix. This is a very long and it can be tricky if you don't know the concept. Even if you know the concept, it can trip you up if you're under like interview pressure. So, you know what they say, practice makes perfect. So, I'm going to practice this. You see, I've done this like 2 times. So, and I get it right, but it's just the time complexity. Like, it's so strict on Leetcode in Java. So we are given a n by n binary matrix grid. We need to return the length of the shortest clear path in the matrix. And if there is no clear path, we need to return -1. Okay. A clear path in a binary matrix is a path from the top left cell, 0, 0, to the bottom right cell, n minus 1, n minus 1, such that all the cells of the path are 0. Yep. So all the adjacent cells of the path are 8 directionally connected. So, okay. So we can move in 8 directions this time. And we need to return basically the shortest path, length of the shortest path in the matrix. Okay. So some clarifying questions I would ask here is basically, one, is grid guaranteed to have 1 and 0 only? No grid. How do you want to handle that? Do we just want to return 0? And then, yeah, we just need to basically solve this problem. So, because this is like a shortest path problem, you want to use breadth first search to go layer by layer. And what do I mean layer by layer is basically, we see at 0 here, the first layer is 1, 0, and 1. And at the here, 0, the first layer is 1, 0, and 1. And then when we're here, the next layer is 1, 0, 0, 1, 0, 1, 0. So breadth first search will ensure that we visit every cell level by level. So the first time we are at a level where we reach the bottom right cell, we will know that we already have the shortest path and we can just return this answer. So that is basically my solution. So solution 1, BFS layer by layer in grid to find shortest path. So we would need a queue, and the type would be a basically, what do we contain in the thing here? It would be an integer array. Should I use a pair or an integer array? I think the last time I used a pair and this shit like timed out, which pissed me off. Yeah, I used a queue with int and it timed out, even though it's right. So I think I need to use a pair. Okay, for some reason that works. So it's weird, but it would just be more simple for me to use a int. It's just shorter, and because we're under time constraints. But let me start. So it would be a pair of basically an int for the coordinate and an integer for the current distance. Int would be x and y coordinates, and integer would be the current distance. And yeah, so we just do BFS. So the time complexity of this, and to ensure that we don't add duplicated cells, we need to maintain a set of basically int to avoid visiting duplicated cells. Okay, so the time is O of m times n, where m is number of rows and n is number of columns. And the space complexity here, we have our queue, which in the worst case will contain every single element. So the queue in the worst case is O of m times n. So for example, like this one, it would be O of m times n. Yeah, the space and time complexity is here. Let me go ahead and implement my BFS solution. So a case I can see is when grid at 0, 0 is equals to 1, then we can't make a valid path. And grid at m minus 1, n minus 1 is equals to 1. So let me get m is grid length, n is equals to grid 0 length, just like that. So if grid is equals to 1 or grid at index m minus 1, n minus 1 is equals to 1, we can immediately return 0. Otherwise, we do a BFS here. So Q of pair. I hate Java, man. The syntax is so tedious. Integer here, call it BFS is a new linked list. So it will be like a x, y, and then like the pair would be a x, y, and a distance so far. Okay, and then we need a set of int. Should I maintain a set of int or a set of string? Like which would be faster? I don't know. Let's just do a set of int. Well, let me ask ChatGPT. Can I maintain a set of int in Java? Because it can be weird. You cannot directly store an int. So it would be a set of string. Call it visited. Is a new hash set. So what this will contain is, for example, a string of like x comma y for the visited coordinates. So initially we want to add to the BFS a new pair of basically a new int of 0, 0, and the distance would be initially 0. So here the distance is 2 because 1 and then 2. Here the distance should be 3. Whoa, it's 4? 1, 2. Oh, yeah. 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4. Oh, we can skip this one. Okay, so the distance is 1 initially. And visited will be adding basically a new just to be space efficient, new string builder of basically 0, plus, comma, plus 0 to string. Okay. Okay, so now while BFS is not empty, we need to process basically level by level. So let's do a here. This is just a placeholder because we know that BFS will always encounter everything. So we just return -1 here as the distance. So let's get a pair. Let me just copy this. Current coordinate or current pair is equals to BFS remove. So we are removing from the front of the queue. So let's get the distance. So int xy is equals to current pair get key, and then int distance is equals to current pair get value, like that. And so now we just check if basically xy at index 0 is equal to m minus 1 and xy at index 1 is equals to n minus 1, then we just immediately return the distance. Otherwise, we need to visit all 8 fucking directions. So let me make a direction array here. So int dir is a new int that contains, let's do 0, 1, well, 0, 1, 0, -1, 1, 0. Man, I hate defining this. 1, 0, -1, 0. 0, 1, 0, -1, 1, 0, -1, 0. Now we move on to 1, 1, and then 1, -1, and then -1, 1, and then -1, -1. So this is the 8 directions here. Yep, yep. 1, 1, 1, -1, -1, -1, 1. Okay, so now if we haven't found the distance, we need to visit the neighbor. So visit and add unvisited neighbors to back off queue, BFS. Okay, so for int dir in the direction array. So let's get the new x. So int new x is equal to basically xy at index 0 plus direction at index 0. And then int new y is equal to xy at direction 1 plus direction at index 1. So we need to check for out of bounds. So if basically new x is less than 0 or new y is less than 0 or new x is greater than basically equals to m, or new y is greater than or equals to n, or visited contains basically the key already. So let me break this into 2 lines. New string builder to string. This is so tedious, man. Of basically new x plus comma plus new y, just like that. Then we basically don't add this continue. Otherwise, you add to the back of the queue a new pair. BFS add a new pair of new int containing new x and new y. And the value would be distance plus 1. Okay, we want to make sure that it's also valid. So another check I forgot here. Man, this is so long. Or basically our grid at new x and new y is equals to 1. Then we also want to skip because it's a block cell. So now we should have our answer if there's no syntax errors here. Yep, new hash set. I forgot to add a comment here. Okay. This should be a double equal. Jesus Christ, man. We get a wrong answer. And we are returning here the case where 1, 0, 0. So yeah, we should return 0. Why didn't it return 0? Because we know that we are blocked here. So why isn't this return? Why is it returning at line 45? Because grid at 0, 0 is equal to 1, right? Oh, you want to return -1. Oh, okay. So here we just do -1. So my return type is wrong. Yeah. Do not time out, bro. Oh my god, this shit is gonna time out. Dude, I don't understand why in Java this shit times out. Because if this was during like a real interview, we wouldn't get to run the code and this shit wouldn't time out. So where do I need to optimize this here? Jesus, I hate this problem. Okay, I'm using a pair. Oh, it's a Boolean array. Okay. So instead of maintaining a visited set, we just do a Boolean. Jesus. Boolean array visited is a new Boolean of size m, n. All right. So visited at index 0, 0 is equals to true. All right. And visited here and visited at index new x, new y, then we continue. Otherwise, you add visited at new x, new y is true. And hopefully this passes. You know what I'm trying to do, bruv. What's the issue here? Oh. All right, let's see if this shit times out. Fucking time limit exceeded. All right, it doesn't time out. This is so stupid. Okay, so next time I need to maintain a Boolean array of visited. So usually, this is kind of dumb, but another question that they could ask you is instead of storing the distance, you want to store a path. So basically, instead of having a integer, we want to modify it would be a list of integer here for the path. So pair, and then this would be the path. Okay, new int, and then a new array list, and then arrays as list. Basically, man, 0, 0 as the coordinate. All right. We don't do the distance here. We do a list of string, call it path, is a current pair get value. Okay, so if we found the current path, then we do a for string coordinate in path. We basically system out print C plus a space, because the follow-up or the variation would be just to print out the path here. Okay, so now we need to deep copy every path. So here you need to do a list of string path copy would be equal to basically new array list of path. Okay, and then you want to add path copy, add basically new x plus. So you want to maintain the correct format plus new y plus the closing parentheses like that. And then here it would be a new, man, this is tedious, path copy like that. New pair list cannot be converted here. Oh, where's the bug here? So pair of int and list of integer. Right. New int, new array list. Man, there's so many. So let's get a list of string. Oh, it would be a list of string. Sorry, fuck. So list of string. This should print out. Oh my god. List of string. Cool. So it's printing out the path here. You see 0, 0, and 1, 1. So let me fix. So in the first case, 0, 0, and 1, 1 would be the path. And then here, 0, 0, 0, 1, 1, 2, and then 2, 2. So it's printing out the correct path. So yeah, this is the variation. So the time complexity of this is because we need to make a deep copy. So O of m times n times m times n, because we need to make a copy of the current size of the list at every input. So yeah, this is the variation. I'm gonna see if I already submitted this. I know it's wrong. I'm gonna submit it. Cool. And I'm gonna go to the submission variation where print out the path from start to end. Cool. So shortest path is done. Super fucking tedious, but we got through it, guys. So hanging tight in here. We've done make a good progress today. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So about 20 more problems. We've been live for 2 hours. I'm tired, but I'm going to keep going. We have 3 people watching. Nice. All right. Yeah. So for the new people who just joined, I'm just going through Meta's top tag questions here. And I started at clone graph today. And now I'm currently at this problem. So we have about 20 problems to go. This should require like another 2 hours or something, man. But I'll try my best to get through it. And then tomorrow, or when I have time again, I will go to the bottom and do all these problems. Holy shit, this list is long. I'm gonna do all 500 because that shit would be impossible. All right, range sum of BST. This should be easy. Given the root node of a binary search tree and 2 integers low and high, return the sum of values of all the nodes with a value in the inclusive range low and high. So root here, we're given this tree, and low is 7 and high is 15. So we see that 7, 10, and 15 are in the range. So we add 7 plus 10 plus 15, and we return 32. Pretty straightforward problem. Some clarifying questions that I would ask is, I would first confirm the structure of tree. So is it a BST with, left and right pointer and a value? So basically, left subtree will contain val less than root val, and right contain val strictly greater than root val, like that. I need to confirm that with the interviewer. Also confirm how to handle root equals to null. Just return 0. And let's see. Confirm that no integer overflow, because we are doing a sum for sum. So we don't want to go over the max integer or over the minimum integer, right? So range is from min int to max int for sum. And yeah, that would be basically it. And then I would dive into my solution by just calling a DFS, going left or right of a tree based on the current root value. So we know that this is a binary search tree. So if current val is equals to is greater than high, then skip right subtree and go left, and vice versa. If current val is less than high, then skip left subtree and go right. Pretty straightforward. Time is O of n in the worst case, because we have to visit every node in the tree where n is num nodes in tree. Space would be height of the tree, so it could be log n or n in worst case where tree is linked list for recursion stack, and log n for balanced tree. So that's basically it, man. Pretty straightforward. I can do this iteratively, or I can also do it recursively. Let's do it recursively. If root is equals to null, we just need to return 0, and then we can do a pass in a global sum. So int sum, set sum is equals to 0. We call DFS on the root, and then at the end we just return sum. Private void DFS takes in the tree node current. So if current equals to null, we just return. Otherwise, we check if current is within range. So if let's make low and high global variables. So int low, int high. Cool. So this low equals to low, this high equals to high. Cool. So if basically low is less than or equals to current val, and current val is less than or equals to high, then we want to do a current sum plus equal to basically current val, and then we check to whether go to the right or the left subtree. So if current val is greater than the high already, then we is still less than the high, then we want to do DFS current right. And if current val is greater than the left, then we can do DFS on current left. This would be the solution. What did I name it as? I just name it as sum. So this should be sum. This would be low. Cool. Submit. Pretty straightforward question. Let's try and do this iteratively. Okay. So we can just use like a queue basically to add all the nodes that are part of the tree. So we can use a queue, or can we use a stack? I don't think it matters, to be honest. Queue or stack, we just need to process all nodes that are part of the tree. So since it's DFS, I'm just going to use a stack of tree node, and st is a new stack. And then if here root equals to null, return 0, and then int sum is equals to 0. Okay, so while basically stack is not empty, we get the tree node current is st pop. So we want to add st push the root. So current, we check if it's within the range. So if current, if low is less than or equals to current val, and current val is less than or equals to high, then we want to do a sum plus equals to current val, and then check to see if basically current left doesn't equals to null, and current val is greater than left. Then we do a stack push, basically current left. And then similarly, if current right doesn't equals to null, and current right is less than, this should be low, less than high, then we can basically do a st push current right. And at the end, we just return the sum. Pretty straightforward, man. Oh, current val. Yep. I wish I get asked this question in a fucking phone screen. That would be the dream. But uh yeah, is there a reason? So I don't have to keep passing everything into the recursive function. So let me show you. To answer your question, right? If I didn't make low and high global variables, I would need to pass in to the DFS function, so which would waste time. So the DFS function, instead of taking only the current node, it would take in the low and the high. So every time I call DFS here, I have to write more. It's just duplicated value. So once I make it here, I only have to declare it one time down here as global variables. I hope that answered your question. If you're still watching, Sherwin. And thanks for watching, by the way. Uh, I hope that answers your question. So I just to sum up, I made them the low and high global variables, so I don't have to pass them as parameters to the DFS function, which would increase my coding speed because, as you see, I code DFS here 2 times. All right, so move zeros, another favorite problem. I solved this my own way, so almost there. After this, we have these questions. Pretty fast. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 questions remaining after move zero. So let me start this. I hope I answered your question, Sherwin. Move zeros. So we are given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. And we must do this in place without making a copy of the array. So if it's here, this is our given array. We need to 1, 3, and 12. We need to move those to the front. And the 2 zeros are moved to the back. So yeah, this is pretty straightforward if we use two-pointer solution. So before I begin to explain my solution, I would need to ask some clarifying questions. So basically, how to handle nums is null or empty. Okay, and then is it guaranteed? That nums will be within valid integer range. And yeah, it's a pretty straightforward question. I think it's probably better for me to draw this to explain the solution. So let me copy this example here and explain my solution. So I'm in Excalidraw. So let me do a 8 and paste my thing here. So we want to maintain 2 pointers. So we want to call the first pointer, call it 0 index, and the second pointer, call it the current index. Current index. So the 0 index will always be, how do I select something? This is how I select. Okay, so let me write it down here. So 0 index is first index from left to right, where nums at 0 index is equals to 0, and the current index is 0 index plus 1. So in this case, the first 0 from left to right happens to be at the first array. So what we do is, if the current index is not a 0, we do a swap of current index with 0 index. So we do the swap here. Basically, our int array, let me copy this, paste. Well, that doesn't work. So we do the swap. So this becomes 1 and this becomes 0. And so now 0 index moves forward to here, and current index also moves forward. We check, we see that 0 is not 0 at current index, so we move current index to 3. Now we see 3 is not 0, so we do the swap of current index with the 0 index. So here, this becomes 3 and this becomes 0. We have to move 0 index forward, and the current index would also be moved forward. So again, current index is at 12. So we can swap with the 0 index here. So this becomes 12 and this becomes 0. So then we move 0 index forward and current index forward, and we are out of bounds, and we have the correct answer. So that's basically the logic, man. We just need to set 0 index to the first index from left to right when nums 0 doesn't equals to 0. And with this current index at 0 plus 1, whenever we encounter the current index that's not 0, we swap it with the 0 index. And then once we are out of bounds for current index, we would get our answer. Pretty simple, pretty straightforward. So yeah, so the time complexity of this is O of n, and space complexity is O of 1. The naive solution would be to, let's see, basically count the number of zeros, and basically make a list to add all the non-zeros, and then make a second array, add all these non-zeros, and then add the remaining 0. So that solution, the space would be O of n. So solution 1, 2 pointers, and solution 2, make a list of non-zeros, add to front of new array, and return. So this time, even though it's O of n, where n is the number of elements, the space would be O of n as well, because we're making an entirely new array. So let's go ahead and implement solution 1 because it's more efficient. So int 0 index is equals to 0 initially, and int current index is equals to 0. Okay, so now we need to find the first place where nums at 0 index is equals to 0. So for int I equals to 0, I is less than nums length. So let me get int n is equals to nums length, like that. So I is less than n, I plus plus. I don't know why I made this a comment, but basically if nums at I is equals to 0, then we can set 0 index is equals to I, and we can immediately break. So now we can set current index is equals to 0 index plus 1, and then for current index is less than n, current index plus plus. So if nums at current index doesn't equals to 0, then we can do a swap. So nums at 0 index would be equals to nums at current index, and nums at current index would be equals to 0. So then we do a 0 index plus plus, and then at the end this should get us our answer. It's pretty simple once you understand it. Like once you why is it returning that 2 1? Oh, so yeah, I think current index should be here. So this case, it's still wrong. It's returning 0 and 0. So we are making the wrong swap here. So the swap should be int temp is equals to nums at current index, and then nums at current index is equals to nums at 0 index, and then nums at 0 index is equals to temp. So this should take care of all the cases. So yeah, this is the case where there's no 0. So now before I submit, I want to write the possible number of test cases. So 1, where there's all zeros array, and 2, all non-zero array. So for example, this one here, and then 3, array with mix of zeros and non-zeros. So yeah, a little small hiccup, but it works. Let's see the editorial, because Space suboptimal. Yeah, this is the one I propose, where we just get all the non-zeros. Last non-zero found at. Yep, space. I'm here. Yeah, basically we're just the optimal solution that they want is the space complexity of O of 1, because we still need to visit every single node. But yeah, that's basically move zeros. We have 3 people watching. Very nice. So for the people who just joined, I'm just going through Meta's top tag questions to prepare for my upcoming interview. Today I started a clone graph, and I'm now up to 560 subarray sum equals k, and I hope to finish all of this by the end of today, if it's not too late. And tomorrow I will go from valid parentheses all the way down here. And all right, let's move on to the next problem. Feel free to ask me if you guys have any questions. So subarray sum equals to k. This is a good problem. Find peak elements and dot product of 2 sparse vectors. Okay, so after I do those 3 problems, I will have just a little bit left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 more problems. Breezing through it. All right, subarray sum equals to k. Hopefully my computer doesn't overheat or anything. So this is another really, really good problem where you need to know the optimal solution, and there are many alternative solutions. So in a real interview, you would need to discuss like the pros and cons of each solution and the space and runtime complexities and why you choose one solution over the other. So we are given an array of integers, nums, and an integer k. We need to return the total number of subarrays whose sum equals to k. And a subarray is a contiguous non-empty sequence of elements within the array. So for example, 1, 1, 1 here, and k is equals to 2. So we need to find all the subarrays where the sum equals to 2. So as you can see, the answer is 2 because of this subarray, 1 plus 1 is 2. And of this subarray, 1 plus 1 is 2. And we can't do 1 and 1 here because it's not contiguous. So let me start my timer here. If this was a real interview, the questions that I would ask is, let's see, is sum of contiguous array within integer range from negative min int to positive min max int. This is to avoid overflow. So if we have like a nums array where it's like 2 billion, 2 billion, 2 billion, then when we add the sum, we will get an overflow. So that would be the first question I would ask. And then second question, how to handle nums equals to null. And 3, I want to make sure also is k within int range. So it would be valid int range. These would be the valid clarifying questions. So yep, we're given a range here. Okay, so let me basically come up with different approaches for this problem. So solution 1, the naive solution, would be to brute force, basically find all sub arrays and increment count whenever a subarray equals to k. So the time complexity of this is O of, let's do here, we need this one, and then we need to keep expanding. So it's O of n squared where n is number of LMs in nums, and the space would be O of 1. But we don't want an n squared solution, so let's do solution 2, which is a prefix sum solution. So basically, we know that, for example, 1, 2, and 3, right? So let me just do this and explain it. So the prefix sum would be 1, and then 1 plus 2, which is 3, and then 1 plus 2 plus 3, which is 6. And our k is equals to 3 here, okay? So how do we know how many elements are part of our result? So here we know that 1 plus 3, so the prefix sum here is 3, so we increment our count, it's 1. And then when we're here, we see that in order to find 3, we need to take 6, and minus k is 3. So how many times does 3 appears in the prefix sum? 3 appears one time. So we know that we can increment count, because this subarray by itself alone will give us k equals to 3 as the sum. So that's the prefix sum solution. It might be confusing because this is such a simple example. So let's do like 1, 0, -1, and then like 2, and then -2. And k is equals to 0. So we need to find all the subarrays that are continuous and adds up to 0. So let's do a prefix sum here. So 1, 1, 0, plus 2 is 2, and then 0 as our prefix sum. Just like that. Okay? So right away, we can see the count here. This one is already equals to 0. So count is 1, and then 2. We want to check how many times 2 already appears in the array. None. So we keep going. We see another 0 here. So count is equals to 2. So here we know that this one sums up to 0. So prefix sum 0 minus 0 here. I guess this is a bad example, but it should be the prefix sum. So let me think of another example. So let's build off this 1, 2, 3, and let's do like 3 as well. So the prefix sum, let's do 1, 3, and then 3 plus 3 is 6, and then 9. Okay, so we know that, and then we can do a -3 here. So this could be 0 as the, well, 6 as the prefix sum. Whew. So count is initially equals to 0. As we are building our prefix sum, we see that 3 is what we're trying to find. So k is equals to 3 here. So count is 1. And when we're at 6, we know that if we take this one by itself, then we can have another valid answer. So 6 minus 3, we see that 3 appears once in the array. So we can do that as a valid answer. So it's 3. And then when we're at 9, we know that this alone minus this alone is a valid prefix sum. So 9 minus 3 is 6. How many times does 6 appear in the prefix sum? 6 appears one time. So we can increase count. And then finally, when we're at 6, we are minusing 3 again. How many times does 9 appear in the array? We know that 9 appears in the array one time here. So this also adds up to our answer here. So it would be 4 as our answer. So that's why prefix sum can do this solution in O of n time complexity. And the space would be O of n, which is more efficient in terms of time than O of n squared. So that is why I'm going to go with the prefix sum solution. Could you suggest some learning resources to improve algorithms and problem solving skills? I would recommend this. So I hope you can see my screen. The Sean Prashant Leetcode patterns. So I would just spend like one day doing all arrays problem, one day doing all backtracking, one day doing graph. And by doing this, you will learn how to recognize the common problem solving patterns. And this is how I personally do it. So I spent like one day doing just all greedy problems, one day doing all heap problems, and then I just have a really good understanding. So let me paste this link here. Hopefully it helps. Spend one day on each topic to learn all the patterns and how to recognize them. So hopefully that helps. If you like what I'm doing, feel free to subscribe. But my thing is dead. Oh, anyway, so this is my solution. So let's do a map of basically integer to integer. Call it sum to occurrence is a new hash map. And basically, let me get the length. So n is num's length. Okay, and then we have k. So now we have to go through and build our prefix sum. We need to first put sum to occurrence, put 0. We need to occur at least one time, because in the cases where, k is equals to 3 and nums is currently equals to 3, then we need to try and find how many times 0 appears in the tree, in the map. So 3 minus 3 is 0. So we need to put this in the map. 0 occurs one time, so we can count 1 as a valid subarray. So int, let's do count is equals to 0. And then at the end, we just return count like that. All right. So now we go through for int I equals, for int n in nums. First, let's get if, well, we can do int to find is equal to basically n minus k, and then now we can do a count would be plus equal to basically sum to occurrence get to find, or the default would be 0, or default to find, or 0. And then now we need to put sum to occurrence, put basically the current sum. So let's do a int current sum is equals to 0. Okay, and then we do a current sum would be plus equals to n. So put the current sum, the occurrence would be 1. So this is my prefix sum solution. N is already defined. Oh, okay. We don't need that. We get a wrong answer here. So there's a problem with our prefix sum. So let's see. The sum to occurrence for 0 occurs at least one time. Okay. Oh, it would be here, sum to occurrence, get or default here, and then you add 1 plus 1 for the current sum, or 0, and then you plus 1. Let's see, sum to occurrence, put the current sum to occurrence get or default for the current sum, 0, and then plus 1. Okay. Let's see. Let me do a quick chat GPT debug here and see where it's going wrong. Where is my bug here? I would like spend time debugging it, but for the sake of time, to find is n minus k. Oh, right. So to find should be the current sum minus k. Yeah, that makes a lot of sense. So to find is equal to current sum minus k. Yep. So, yep. So the mistake was I was comparing basically n minusing k to find the target. But basically, the answer should be like that. So hopefully, fingers crossed. Yep, it does go through in O of n time complexity. So the small bug here. So usually when I go through these problems and I make a mistake, I need to note down where I make the mistake. So in this case, mistake was on line 29 and line 30. So mistake on line 29 and 30, need to add current number to current sum, then minus k to find the target prefix sum. So that's a note to myself. This is a pretty tricky problem, not gonna lie. But the brute force is O of n cubed for some reason. Cumulative sum. Yeah, this is my O of n square solution. And yeah, O of n square. This is the first solution I propose. And prefix sum is O of n. Yep. So it's tricky. Like once you understand it, you just kind of understand it. But if you don't understand it and they want you to come up with the optimal solution during the interview, then you are kind of screwed. So you need to do a current sum plus equals n here, and then to find would be current sum minus k. So you are trying to see if there's a subarray in the current giant consecutive array where the sum is equals to k, basically. Hopefully my explanation makes sense. Yeah, thank you. Yeah, no problem. Thanks for watching. Let me know if you have any questions. Um, let me know what role you are going for. And yeah, feel free to subscribe if you find this helpful. Um, if you want, I can do like a Q&A session where I can just answer your question and basically kind of guide you on the best way to start getting into Leetcode and practicing. I don't mind doing that. But back to the problem. Cool. Oh, I need to leave this so I can redo tomorrow. So usually when I find a tricky problem that I tend to make mistakes on, I just leave a comment like do tomorrow, and then I don't close out of this tab. So these three problems, I need to learn the new solution, the most optimal solution for. So I leave them here. And this one I need to redo to cement the concept. So anyways, we move on. Almost at the very beginning. It should be a breeze to go through these problems. So let's keep going. Find peak element. Let me take a quick water break. What time is it? 9:38. We should be able to get everything in the next hour. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, back to work. Find peak elements. Start the timer. A peak element is an element that is strictly greater than its neighbors. Given a zero index integer array nums, find a peak element and return its index. Okay, so it's an element that is strictly greater than its left and right neighbor, I'm assuming. So if the array contains multiple peaks, return the index to any of the peaks. And you may imagine that nums at -1 equals to nums at n equals to negative infinity. So in other words, an element is always considered to be strictly greater equal than a neighbor that is outside of the array. Okay, and we must write an algorithm that runs in O log of n time. That makes a lot of sense. So without a visualization, it's kind of hard to see what the question is asking. Excuse me. So a peak element is an element that is strictly greater than its left and the right neighbor. So in this case here, we see 3 is greater than 2. So it's greater than its left neighbor, and 3 is greater than 1. So it's greater than the right neighbor. So 3 is a peak, as the problem explains here. And here, 2 can be a peak because it's greater than its left and right. 6 can be a peak because it's greater than 5 and 4. And so the naive solution for this would be to do like before I dive into a solution, I want to simulate like real interview experience where we need to ask clarifying questions. So some questions that I would have is one, what if array all contains the same number? So like 1, 1, 1, 1. Will this ever happen? So what I'm trying to say is a peak guaranteed? Okay, so there's no here. It clarifies that there's no neighboring where they are the same. Okay, so another question I want to ask is I guess, is nums within int range? Not really necessary, but still good to ask it. And that's basically it. And so let's go into discussing the possible solutions. So solution 1 would be to like just go through and compare each LM to left and right neighbor. If an LM is peak, return. But the time complexity is of n, where n is num of LMs and space is of 1. So in this case here, we compare 1 with negative infinity and with 2. Not a peak. 2 with 1 and 3 not a peak. 3 with 2 and 1. So we return 3. So that's the brute force solution. Another solution I could think of is solution 2 is a stack. We can maintain a monotone increasing stack. First time encounter a decreasing element, return top of stack. So for example, our stack would be like 1, 2, and 3. So 3 would be at the top of the stack. And then when we encounter the last 1 here, we check that 1 is less than the top of the stack. So you just return 3 because we know that's a peak. So the time is still O of n. And space here is worse. It's O of n in the worst case. Okay. So the optimal solution here is we can basically use binary search. Solution 3, binary search. And it's kind of hacky. You just need to be able to visualize this. So let me just draw this, go through this binary search to make you guys understand. So if we have 1, 2, 3, and 1, we first start the left to be here and the right to be here. And the middle will be here initially, right? So we are trying to find the maximum element. So we want to check the mid with its mid plus 1. So if mid is less than mid plus 1, then you know that this one cannot be a peak because peak has to be the greatest. So we then move to left is equals to mid plus 1 here. Okay, so now let me delete this. So now we have right and left here. So mid is now here, right? So mid, we check here 3 with 1. We know that this could potentially be a peak because 3 is greater than 1. So then we move right to be mid. So right is also here. And now left is no longer less than right. We just return nums at left, which is 3 as our peak. So it's just basically take advantage of basically if the nums at mid is less than nums at mid plus 1. Bro, shut up. That's my Google Home. If nums at mid is less than nums at mid plus 1, then we know that the peak is at the potentially at mid plus 1. So we need to shrink the left window. However, if nums at mid is greater than nums at mid plus 1, then this is currently a peak. So we need to shrink right is equals to the mid. That's basically the binary search solution. So the time is O of log n, and the space is O of 1. So I'm just going to implement it. Int left is equals to 0. Int right is equals to nums length minus 1. While left is less than right, let's get an int mid is equals to basically left plus right divided by 2. And then we just check if basically nums at mid is less than nums at mid plus 1, then we know we need to shrink left. So left is equals to mid plus 1. Else, we can do a right is equals to mid, and then we can just return nums at left. And that would basically be our answer. Get a wrong answer here. It's returning 3. Are we returning the index? Oh, we need to return its index. So we return left instead of nums at left. Cool. As you can see, it works in O log of n time. And boom. Pretty straightforward problem. I think the variation for meta is find minimum element. So instead of peak, it would be like find minimum peak. So here, let's walk through an example of meta variation. So find local minima. It would be like 4, 3, 6, or 5, and then 6, 4, or 6, 3, 5. So the minima here would be 3 because it's less than 4, and 5, it's left and right neighbor. And it would also be this 3 because it's less than 6 and 5. So this case, we just modify the binary search. Left and right, mid. If nums at mid is basically greater than nums at mid plus 1, then we know that there's no minima at mid. So we need to do a left here as mid plus 1, and then else, the other case is nums at mid is less than or equals to nums at mid plus 1. Then we need to do a right is equals to mid because this could potentially be a minima. But yeah, that's basically this problem. Pretty straightforward. All right. Where do you recommend starting on Leetcode as a beginner? A roadmap would be helpful. Yeah, so I would recommend Leetcode. He gives you a roadmap right here. So Leetcode.io. I hope you are still watching. But yeah, this would be the roadmap. Oh, it's kind of buggy. So you would start with array and hashing, do all the problems in array and hashing, then move on to 2 pointers and stack, and just keep going until you get to the most advanced one. I would say like spend most of your time on array, 2 pointer stack, trees, tries, backtracking. Yeah, all the way here. The dynamic programming, 2D dynamic programming is like way more advanced, and bit manipulation is rarely asked. Math and geometry, this is like the less common type to worry about as a beginner. So just start with whatever is at the top and the left side of the tree here. Let me send you this link. Hopefully this helps. That would be the what I would recommend. All right. We keep going. How long have I been doing this? Fucking holy shit, 3 hours. That's crazy. All right. Almost there. So dot product of 2 sparse vectors. this is a very good meta problem because there are so many like follow-up questions and multiple implementations. So I guess what I'm gonna do is try and code all three solutions, and hopefully we can make it through everything. And then sum array sum equals to k. Oh, this is for tomorrow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 problems. We have 2 viewers now, so I guess you guys are going to bed. Have a good night, and I will be here until I'm done with all these problems. Dot product of 2 sparse vectors. Let me reset my timer here. So given 2 sparse vectors, compute the dot product, implement the sparse vector class, where the constructor takes in a num and initializes the object with the vector nums, and the dot product, compute the dot product between the instance of sparse vector and the input vector. And a sparse vector is a vector that has mostly 0 values, and you should store the sparse vector efficiently and compute the dot product between 2 sparse vector. And what if only one of the vectors is sparse? Okay, so let's answer the question, discuss all the potential solutions and trade-offs, and basically try and have a discussion as if it was during a real interview here. Okay, so the naive solution. So let's walk through an example first. So if these were the 2 sparse vectors, we would do 1 times 0. So 1 times 0 plus 0 times 3 plus 0 times 0, and so on. And the sum would be 8. This is very inefficient because the time complexity of this would be O of n, where n is the minimum length between the 2 sparse vectors. And there's a lot of zeros, so we are doing unnecessary input computation. So before I go into the solution, I want to ask some clarifying questions. How do you want to handle will nums ever be null? Hopefully not. Dot product of 2 sparse vectors. Range of nums. Will the dot product overflow because exceeds max or mint int values? So negatives, overflow, duplicates, that doesn't really apply to this problem. No input. That's about it. So these would be the clarifying questions. I guess the most important one is like the overflow, because you don't want to, you want to know what to create the dot vector return type as. Okay, so the naive solution, so solution 1, just go through nums and multiply every lm to find dot vector. The time would be O of the min between vector 1 length and vector 2 length. Space would be O of 1, but we don't want to do that. Solution 2. Let's see. We know that the vector is very sparse, so we can basically store the index and the value of all non-zero indexes, of all indexes where the value is non-zero. So here, nums1 in our hash map, we will contain index 0, 1. So store index to value of all indexes where val is non-zero. So time would be O of the min between the map 1 length, which is the map of vector 1, and then map 2 length. This would handle the sparse vector case. However, there are some trade-offs here, so pros and cons here. So if vector is not sparse, as in the follow-up, here we go, then hash map lookup decreases. It's no longer O of 1. From O of 1 to O of n because of collision resolution, resizing of the hash map, and the hashing function to calculate the key and the bucket. So another solution here is, instead of using a hash map, we could store a list of pair where it would be the index and the value for each vector. Then this would be solution 3. For two vectors, get the vector with less pairs and binary search in the second vector to see if have pair with same index. So the time complexity of this is O of we do a n and then log m, where n is less than m and n is length of smaller vector and m is length of bigger vector. And it's log of n because we're just doing binary search n number of times. And the space complexity is still O of basically n plus m. Here, the space would be O of m plus n again. Here, the space is O of 1 if we don't count nums as additional space. All right, so I'm going to implement solution 3 for the sake of time, because solution 2 is pretty straightforward. You just use a hash map. But as we discussed, if the vector is not sparse, then the hash map lookup time will lookup performance will decrease from O of 1 time complexity to O of n because of collision resolution. Resizing of the hash map and the hashing function would take a lot of time. And yeah, so I'm going to go ahead and implement solution 3. So let's do a list of int, call it vectors, and then we do go through initialize vectors is equals to a new array list, and then we just go through here. So for int I equals to 0, I is less than nums length I plus plus, we just check here if nums at I doesn't equals to 0, then we want to add this to the vectors, add a new int of the index, which is I, and then nums at I, like that. And we want to have a variable size is set to be equal to vectors size. And that is to basically use to find the vector with less pairs, less number of pairs. So here, if let's set vector 1 is equal to this vectors, and then vector 2 is equals to vectors, and then we check the size. So if vec1 size is greater than vec2, well, if this size is greater than vec size, then we want to switch. So we want to have vec1 to always be the smaller vector. So smaller vector always. And this should be the bigger vector always. So if this size that is supposed to be small is greater than the other vector size, then we need to do a swap. So list of int temp is equal to vec1, and then we do a vec1 is vec2, and then vec2 is equals to temp. So we do the swap, and now we need to just go through smaller vector list and call bind search to find dot product. So int prod is equals to 0 initially. Okay, so now for int v in vec1, let's do an int other v. So other v is equals to bind search on the index. So it would be v at index 0, and then if basically other v doesn't equals to 0, then we can do a product. The dot product would be plus equals to basically v at index 1 times the other vector, and then at the end we just want to return the dot product just like that. So now we just got to implement our binary search function. We are passing in the thing we are trying to find, and we need to pass in the vector 2. So now private, it would be a int binary search, and then an int target, and then a list of int vectors. Okay, so let's get left is equals to 0, right is equals to vector size, and then -1. So this is just a simple binary search. So while left is less than right, basically if we find, let's get mid. So int left is less than or equals to right, int mid is equals to left plus right divided by 2. If basically vectors get mid at index 0 equals to the target, then we just return we have found the corresponding vector at the current index we are looking for, so we return 1. Else if vectors get mid at 0 is less than target, so we miss our target, then we do a left is equals to mid plus 1. Else we do a right is equals to mid minus 1. And if we don't find anything, we just return 0. So this should vec1 is this vectors list of int like that. Cool. Man, that solves it in the case where the hash map doesn't work. So binary search, we are trying to find an exact value. That's why it's a less than or equal, and we have this case. So it's just simple binary search. I did write a big ass follow up here. So let's see. What did I write? So the naming is better here. We are doing the swap. We're doing the binary search. Where's my explanation? I want to see my notes where I discuss the trade-offs. This is the two-pointer solution, which would require L1, L2. Oh, so I forgot to discuss this solution. Okay. What other solutions do I have? Read me right here. Hash map solution, when and when not to use. So bad if one or both vectors are not sparse. So this is the hash map solution because of the overhead of hash map, collision resolution, resizing, and hash function computation. Yep, that makes a lot of sense. Cool. So dot product is basically done. I forgot the two-pointer solution here, but that's also inefficient. So I guess what I could have discussed here is the map solution and then two-pointer solution and then binary search solution as the most efficient here. Cool. Hey man, which question is this? What do you mean? This one? Dot product of two sparse vectors? It's a top meta question. Top meta tag question. So if you just joined, I'm just going through the top meta tag question. Almost done. Well, like 13 more problems, then I get to sleep, and then I gotta wake up at like fucking 7 tomorrow to go to work, but it should be fine. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Nice. Are you interviewing for Amazon or what? Senket. Sorry if I'm mispronouncing your name. You are working at Amazon? Oh, nice. I am currently in the process of grinding for. Oh, not yet. Have you been grinding Leetcode? Not yet. All right. But yeah, man. Yeah, you need Leetcode as a developer. I wish they teach you this kind of shit in school, but they don't. So you just gotta spend the time and do it. Anyways, back to work. Yeah, if you like what I'm doing, yeah, man. Make sure to subscribe, and if you have any questions on how to get started with Leetcode or any advice on how to interview prep, feel free to leave a comment, and I'm happy to help you. Thanks, man. 13 more questions, then I go to sleep. Merge interval. This one is easy. This one is a trick question. The power of xn. Lowest common ancestor is pretty easy. Simplify path is easy. All right, let's knock out those 4 and we'll just tackle them like 4 at a time. Sweet. Thank you. Merge intervals. Okay, given an array of intervals where intervals I start n, merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. So it's for these kind of questions, it's always best to just go through an example. So let me start my timer. So as you can see here, 1 and 3 overlaps with 2 and 6 because the first interval ends at 3. However, the second interval starts at 6. So we merge them into 1 and 6. So now we check 1 and 6 with 8 and 10. There's no overlap because it ends at 6 and we start at 8. So we keep going. 8, 10, and 15, and 18, there's no overlap. So we just return this list. Yeah, pretty simple, straightforward. If this was a real interview, I would ask, first of all, um, one, no duplicate interval or not. So, for example, there wouldn't be like 1, 3, and 1, 3 because that would just be a waste of time, right? Um, is it guaranteed that in an interval, uh, start will always be less than or equals to n? And then 3, overlap. So will 1 and 2 overlap with 2 and 3? Or because we end at 2 and we start at 2 right away, there's no overlap. So overlap or no. So when endpoint is same as next start point. So these would be the questions that I would ask. And then another one is how to handle when handling intervals equals to null. So I would ask these interviewers, the interviewer, these questions first before I start my solution. And as you can see here, it does count as an overlap 1, 4, and 1, 5. So yes. Start is always less than or equals to n. So the interviewer would confirm. No duplicate. Let's just assume that there's no duplicate. And then, yeah. So my approach is just to basically solution here is maintain a previous interval. If no overlap, add prev interval to result list, and current now becomes previous interval. And if overlap, merge current interval with previous interval, kind of like what I just did when I walked through everything. And at the end, just return result list. The time complexity is O of n, where n is the number of intervals here, and space complexity is O of 1, because we're not creating any additional variables. So to walk through a problem, previous interval would be this one, 1 and 3. And when we're at 2 and 6, we see that there's an overlap. So we merge into 1 and 6. So now previous interval is 1 and 6. And now current interval is 8 and 10. There's no overlap. So we add 1 and 6 to the output list. And now the previous interval is 8 and 10. So when current interval is 15 and 18, there's no overlap. So we add 8 and 10 to the list, and the previous interval is 15 and 18, and we are out of bounds. So we just add the current interval, previous interval to the list, and that is basically our answer right there. So let's do an int, call it previous interval is equals to intervals at index 0. Well, before this, another question I forgot to ask is, will intervals be sorted in any way? And the answer would be no. So first we want to sort interval by starting time, ascending, just like how the example is given to us here. So this example kind of gives us a hint. We need to sort like 1 starts before 2, starts before 8, because the input can be given to us like 8, 10, and then 1, 3, which is unsorted, right? So array sort intervals comparing A and B. We do a basically A0 minus B0 for the start time. And then we get the previous interval. So now for int I equals to 1, I is less than interval length I plus plus. And then we have a list of intervals here, call it interval list, is equals to a new array list. Okay, this will be useful now because we don't know how many overlapping intervals there will be at the end. So we don't know the exact size, okay? So interval list is like that. And then now we get an int current interval is equals to intervals at index I here. So let's compare. If there is an overlap, so if previous interval end time is greater than or equals to current interval start time, then there's an overlap. So we do a previous interval. Start would be equals to the math max. Well, it would be the math min between the previous interval index 0 and current interval at index 0, and previous interval 1 is equals to math max between previous interval at 1 and current interval at 1. Okay, else there's no overlap, then we know we can add to the interval list the previous interval. So previous interval, and now previous interval becomes the current interval, just like that. Okay, so overlap. So at the end, we always want to add to int list, add the previous interval, just like that. And then now we just return interval list to array, a new integer array of int list size, just like that. Cool. Cool. Pretty straightforward. I've done this shit like 500 times, man. God damn. I have no life. We have 5 people watching. Nice. That's crazy. If you guys like what I'm doing, feel free to subscribe and like the video. It would help. Also, I can't see who's watching, so I don't know why you guys are leaving. I know that some of you guys like might be my friend or something. Like I can't see who's watching, so we have 6 likes. Nice. If you guys have any advice on like how to start with Leetcode or how to learn and practice effectively, feel free to ask in the chat. But I'm just going through everything here, and I can't see who's watching. So yeah. Anyways, we keep. This one is kind of like a trick problem. You kind of need to know the trick to solve it effectively, but I'm just gonna go through it anyways. So implement the power x of n, which calculate x raised to the n. So like this. So for example, if x is 2 and n is 3, we calculate 2 to the 3. So x is 2, n is 10, we return that. Yeah, pretty straightforward. So some clarifying questions I would ask before starting this question. Let me start the timer here. So 1, range of x and n can be negative or no. So can be 0, and then 2 will overflow or not, because say this case where like say n is like 1 million, then it will overflow. So yeah, the interviewer would then clarify all of this with me. 5 people watching. I can't see who's watching, so don't worry. That's 4, bro. That's funny. But yeah, let's go with the non-optimal solution and basically just do what the code is asking. So non-optimal brute force, where the time complexity would be O of n, and the space complexity would also be O of n for recursion stack. And then we have solution 2, optimal. This is recursive, and then solution 3, optimal iterative. Okay. Optimal. Okay. So, okay, let's do the recursive solution. So, I know Leetcode will not accept this, but I'm just still gonna do it because it just shows how I'm thinking. Okay. So first case is if let's see, can x be, n has to be greater than 0, and x can be negative, and n can also be negative. Okay. So we check here the base case. If n is equals to 0, then we just simply return, say 2 to the power of 0 is 1. So we always return 1. So, and then here, if x is equals to 0, we just return 0 immediately. Okay. And then if n equals to 1, then we just return x. These are the three base cases. And then we just do a return. Well, we want to check if x is negative, right? If x is less than 0, then we want to return my pal, basically 1 over x, and then we can do a, well, no, if n is less than 0, then 1 over x and then minus n, like that. So those are the base cases. And then now we just return basically x times my pal, x, and then n minus 1. So this is like the dumb recursive solution. Hopefully we get a stack overflow error. So if n is less than 0, return 1 over x and then minus n. For which question do we get an overflow here? Yeah, of course. Let me remove this damn test case here. I just want to demonstrate that there's no overflow, because what test case? Not this one. Yeah, just like a regular case, this solution would work. You see everything is accepted in the recursive solution, but it will overflow if the test case was like negative infinity or negative integer min value. So this is the non-optimal solution. Now I can just explain the fucking optimal solution here. So it's just a dumb property that you just need to know. Like you either need to know it or you don't. And if you know it, you're gonna pass. If you don't know it, then you fail. So for the power, the trick is x to the n. If n divide n is even, so n modulo 2 is equals to 0, then we can just return x times x. It would be x squared, yep, and then times my pal of, no, you just return my pal of x times x, and then it would be n divided by 2. That is basically it. So and then the other case, if n is odd, so n modulo 2 doesn't equals to 0, then just return x times my pal of basically x times it would be n minus 1 over 2. Yeah, my brain is like blanking out here, but that's basically the solution. Like yeah, so the solution of this, the time complexity, would be O of log of n, because every time we are dividing n by 2. So it's more optimal than O of n. And the space for the recursion stack would also be log of n. Let me just double check that I got my time and space complexity right. This is, and the, yep, we take care of that. We do a answer times x, and then yeah, modulo is 2, then you divide by 2, and then minus 1. Yep, that makes a lot of sense. This is the iterative solution here. Yep, what's the time? It's called binary exponentiation. But yeah, basically you do a x times x or x times x times x. Yeah, this is what I was trying to check here. So if n modulo 2, so if n is even, you just do a x times x and you can divide n by 2. However, if n is not even, then you must do a x times x here. That's basically the solution. But let me copy these cases here. Okay. So to take care of out of bounds, we need to make a helper function where n would be a long, which is kind of dumb, but we'll just go with it. So let me make a helper function. So it would be a private double, call it pow, and then it takes in a double x and a long n, just like that. And again, it will have the base cases. If n is equals to 1, return x. If n equals to 0, return 1. Those are the base cases. I think here minus n will go out of bounds. So this case, I just need to return pow of basically x and then n long. Well, here it would be converting this to a long n. And then we have another case. If n is less than 0, return 1 over x and then minus n. Okay, so now we just check if n modulo 2 is equals to 0, kind of like the formula of binary exponentiation. Then we do return pow, basically x times x, and then n divided by 2. And then else, if it's an odd, then return x times x times x. It would be n n minus 1 divided by 2, just like that. And this should I'm missing, oh, this should be pow. Cool. Oh, this should be return pow. Yeah, it's so dumb, but you just need to know it. It is the dumbest question. Like, you need to know the binary exponentiations thing in order to solve the problem. Otherwise, it doesn't, like, it's not going to solve it. So yeah, that's the optimal recursive solution. Let's see, no new comments. We still have 5 people watching. I can't see who's watching, so don't worry. Fuck me. We still have so much to go through, but let's keep going. Fuck it. Like 2 more problems and then plus 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 more problems. I can knock them out in like an hour tomorrow, but I'm gonna try and get as many as I can before like 11. If you guys have any questions, feel free to let me know. But we are 3 hours into this stream. Now I'm gonna try and do the iterative solution. Okay. So for the power here, I just do my iterative solution. So we have n, okay? So while basically n is greater than 0, right? And then we have our double answer is equals to basically 0. Should the answer be 1 or 0? We'll see. But yeah, the iterative solution is a little tricky. So if here we see n modulo 2 is equal to 0, then the formula is x will times equals to x, okay? And then n would be reduced by 2. So n divide equals to 2. Otherwise, else, it's an odd number. So we would do a answer would be plus equal to would it be times equal or plus equal here? My pal, x times x and then n minus 1 over 2. So we are still multiplying x, but answer now will just contain, yeah, so it would be 1, and this would be times equal to the current x, and then we need to do a x would still be times equals to x, and then n is equals to n minus 1 divided by 2. And then at the end, we just return answer like that. I believe this should work. We get a wrong answer here. Let's see. That's because we forget to handle the case where if basically n is less than 0, we just simply return pal of 1 over x and then minus n. N is equals to 1, just return x. If basically x is, well, those cases are taken care of. So I believe this is all I need. Accepted. Cool. This is the iterative solution here. So let me write a note. So iterative solution, binary exponentiation. Yep. All right, done with power. Okay, next one, lowest common ancestor of a binary tree. Pretty straightforward. Ooh, getting real sleepy here. But we still got work to do, so we are going to keep going. All right, lowest common ancestor of a binary tree. So pretty straightforward. Do I even need to do this? I'm just going to skim through it, okay? Given a binary tree, find the lowest common ancestor of two given nodes in the tree. According to the definition, the lowest common ancestor is defined between two nodes, P and Q, as the lowest node in the tree that has both P and Q as descendants, where we allow a node to be a descendant of itself. Okay, that makes sense. So if P is 5 and Q is 1, so 5 and 1, we see that the lowest common ancestor is 3. Let's do another case here. If P is 5 and Q is 2, then 5 is the lowest common ancestor. Vice versa, if P is 2 and Q is 1, I mean Q is 5, then 5 is the lowest common ancestor. It's pretty easy. So yeah, some clarifying questions I would ask before I begin is how do we, one is always the structure of a tree. Will it contain a left and right pointer and a value? And is tree val unique? Because otherwise it would be confusing to find the lowest common ancestor if it's not unique. And then 3, P and Q. What else? How to handle root equals to null. 4, if is it guaranteed P and Q in tree? And that would be basically my clarifying questions. So what are the test cases here? Test cases where root 1, root equals to null, 2 is P or Q is lowest common ancestor, and then 3, root is lowest common ancestor, and then 4, P is on left subtree and Q is on some right subtree of a node, or vice versa. So that's also case number 3. So for example, root is null, then you want to just return null, and P or Q is LCA. Like I said, when P is 5, Q is 2, then P is the LCA here, and root is the LCA. So this example where 5 and 1, and the 3 is the root, and then P is on the left subtree and Q is on some right subtree of a node, or vice versa. So for example, P is 0 and Q is 8, then 1 is the lowest common ancestor. So those are all the test cases. We're just going to do this recursively using depth first search to come up with our answer. So solution 1, DFS solution. Well, DFS, and the time is O of n in the worst case, where n is number of nodes in the tree, because we have to visit every node in the tree to find the lowest common ancestor. So the space is O of the height of the tree, where it could be O of n or log n, because the tree, if it's like a linked list, then the recursion stack will be O of n, and if the tree is balanced, then the recursion stack will be log of n. Okay, so let me check if root is equals to null, or root is equals to P, or root is equals to Q, then we just return root. So this would cover the case where P or Q is LCA and the root is null. Okay, and the next case is, let's see if we can find anything from the left. So tree node, left, in left is calling lowest common ancestor of root left, passing in P and Q, and then tree node in right is equals to lowest common ancestor of root right, P and Q, and we check. So if root is the LCA, then in left and in right will be not null, because when root is P or root is Q, for a subtree we would just return that. So if both are not null, so if in left doesn't equals to null and in right doesn't equals to null, then we just simply return root. And else, if one of them is not null, so let me do here, in left doesn't equals to null, then we immediately return in left, and then else just return in right. GHT, just like that. Cool. Pretty straightforward. I mean, like, if you don't know how to solve this, like, you're gonna fail, man. It's a very basic. Yeah, I haven't done this yet. I'm not doing that, bro. All right, simplify path. Oh, what did I do? Almost there, guys. Like 10 more questions before I end my suffering. Jesus. Water break. Oh, my neck hurts a lot. Ooh, quick break. Simplify path. All right, let's read this problem. Start my timer here. You are given an absolute path for a Unix style file system, which always begins with a slash, and your task is to transform this absolute path into a simplified canonical path. So the rules of Unix is a single period represents the current directory, and a double period represents the previous parent directory. And multiple consecutive slashes, such as 2 or 3 slashes, are treated as a single slash. Okay. Any sequence of periods that does not match the rules should be treated as a valid name. Okay. And the simplified canonical path should follow these rules. The path must start with a single slash. Directories within the path must be separated by one slash, and it must not end with a slash and must not have any single or double periods. Okay. Yeah. So run through some example here. Home, we just return that. Here we just home, and the 2 slash here should be treated as 1. So it just home full. And home user documents, we are doing a double here. I mean a double period. So we remove document and we just have home user and pictures like that. And then here we just have a one leading slash like that. Okay. Pretty simple. Yeah, so to begin this, I would ask some clarifying question. One, let's see, what clarifying questions do I have? Handle no string. 2, how do we want to do? That's about it. Path contains letters, special characters, like what will it contain? And then 3, will it contain spaces? Will it contain spaces? So there's no spaces, which is good. So I guess this is the most important one, because Unix path shouldn't contain spaces. So this should be question 0, the most important question here. All right. So yeah, the solution is just to use a stack. Pretty straightforward. Time is of n, where n is number of LMs between the slashes, and the space is also of n because we need to store those in array. Yeah, so we just iterate through the path string, maintaining a stack. Whenever the current element is a double period and the stack isn't empty, we pop from the stack, and by the end we have our answer. Pretty straightforward. So here, if basically path, let's see, what can I do? Let's have a stack of string, call it directories. Is a new stack. I'll just call it stack, man. And we need a string builder, SB. It's a new string builder. It's like that. Yeah, it's only 10:43. I guess, should I try and do all of these? I can save them for tomorrow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should be a breeze. And what's challenging is these problems that come after. I should focus on, because now, like, the top 40, I'm pretty much straight. So anyways, back to simplified path. So we want to split path by the slashes. So basically, string, call it path array, is equals to path split by the slash. Okay, so then we just go through for string p in path array. We check if p equals, what's wrong with my, then we skip. if p is equals to nothing, like, then continue. Otherwise, there's another case where p equal basically a period, then we want to just get rid of that period, right? Okay. Or p equals a period, then continue. If p equals a double period, then we check. If stack is not empty, then you want to do a st pop. Otherwise, else this is valid, then st push p. Okay, so p is equals to nothing, we skip. If p equals to a period, we also skip. If it's a double period and the stack is not empty, then you pop from the top. And otherwise, we just need to now build our string builder. So what if there's an edge case where it's only a slash? Let's see. We always need to append a slash. So SB append a / always. Okay. So now for string s in the directory. So this should be directory. Okay, so first SB append s, and then SB append the slash, and then at the end we want to return without any leading slash. So return. So we can check here if directory is empty, immediately return SB to string, because this would be the edge case where there's only like edge case where one slash, edge case where there are many slashes. So the stack would be empty, but we should always return this. So I'm right here, edge cases, and then return SB. Well, we want to do SB set length, SB length -1, and return SB to string. And this line is to remove the last slash, because the answer, we never want to remove the we never want the answer to contain the last slash. Cool. Let me see if my test case is added. Let me add another one. Let's say we just have this. Cool. Submit. Solution with clarifying question and edge case descriptions. Cool. So test cases here, like 1, like that, like I mentioned. 2 is that, and then 3 is like that, and then 4 is mix of all period, 1 period, slash, 1 slash, regular path, stuff like that. Pretty easy to come up with. Whew. All right, tomorrow we have these problems to tackle, and then I'm done with the basic top 50 in the past 6 months. God damn. 500 questions, man. That is crazy. So how many questions did I do today? I started from clone graph. So I'm going to do a column counter. Count columns in text. Bro, just give me the tool. So 147 divided by 3. 147 divided by 3. I did 49 problems. Well, 39 problems today. Going over the review, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I did 32 over the top 40. Not bad. Let's check the Leetcode profile. Holy shit. Probably like 100 submissions today. 21 and 22. So like 43. Nice. Nice. Up to 526 questions now in Leetcode. Man. I'm tired, but it was productive and I'm happy I put in the work. Let's see how many people are still watching. We have 3 people. I'm probably going to end the stream here and go to bed because I got to go to work early tomorrow into the office. But thanks for watching. If you guys have any questions, just leave them in the comment. I'll answer them. And I will be back either tomorrow or Wednesday to try and go through all these questions again. But if you find this helpful, like and subscribe. Thanks.